Welcome everybody to the Smart Ships Coalition virtual workshop. I am Andrew Bernard. I'm the director at the Great Lakes Research Center at Michigan Tech. I'm going to give a little welcome here and just some Zoom instructions to get everyone oriented. So I'm sure we're all now almost 2 years into the pandemic, pretty familiar with Zoom, but make sure you've muted yourself if you're not talking, and if you want to turn your video on and off, there's the icons down there for those that are more familiar with Teams or WebEx or some other platform. If you have a question, please feel free to raise your hand. You can do that in the reactions tab and just click the little raise hand and we'll see it and call on you. Or you can type into the chat. So if you just go in the chat and type in a question, we will also take questions that way. If you have any issues, just let Jackie know in the chat and she should be able to help you out. So with that being said, we're really pleased to convene this Fall 21 Smart Ships meeting. Although it's virtual, we expect to get a lot out of this meeting, including where the Smart Ships Coalition is headed in the future. So what we have on tap today is a little update from things we've been doing over the past year here at the Smart Ships Coalition in the Great Lakes Research Center. We've got some presentations from regional partners then at 9:15. At 10:15, we will talk about a Mars site partnership announcement, which is really exciting. We're excited to make a really big announcement here. And then at 10:45, we're going to put you all to work, and we're going to do a little bit of a strategic visioning for the Smart Ships Coalition. So we've got an interactive roundtable set up using Zoom breakout rooms. When we get to that point, Travis will tell us all how to do that. But that should be a really exciting event to get some interaction and to get some feedback from the group as to where we want to head in the future. So that's what today looks like. Again, thank you all for coming. Very, very pleased to have you, and we're excited to have a meeting. Wish we could do it in person, but we're hoping in the spring we can do one in person. So that'll be exciting. With that being said, I'd like to introduce Guy Meadows. Guy's the founding director of the Great Lakes Research Center and really the impetus behind the Smart Ships Coalition. I'd like to give him an opportunity to say a few words. Guy?
Thank you, Andrew. Welcome, everyone. It's great to see everybody here so early. And those of you that are sipping your coffee, please continue to do so. I'd like to give some of the foundation behind the Smart Ships Coalition and what has evolved out of that, including the Marine Autonomy Research Site here at Michigan Tech. Our great thanks go to Eagle, the Office of the Great Lakes. The concept for trying to develop and stimulate autonomy within the Great Lakes region really came from that office. And thank you, Emily, for being here and having such great leadership in that. And it was based on trying to leverage into the marine sector activities going on throughout the state, primarily with the automobile industry and developing autonomy to unheard of levels. And we thought it was reasonable to try and expand that into the marine domain. Also, the Great Lakes governors and premiers have played a major role in getting us to this point. And thank you guys for being here on the call as well. Their insights and their connections across the basin have been invaluable in terms of developing to where we are today. We've also had a tremendous participation by the U.S. Coast Guard, both through Sector Sioux and the Duluth Marine Safety Office. And they have been very collaborative in working out with us, and we expect from this group too to push that further, how to safely operate autonomous and semi-autonomous vessels here in the Great Lakes, being cognizant of the rules of the road and current regulations as this new technology develops. Why here in Central Lake Superior? Well, there's a number of reasons for that. One is we have a very unstructured environment in terms of autonomy. We have really bad weather, so things that work perfectly well on test beds in crystal clear conditions can be really put to a test here in terms of low visibility, obstructions such as floating ice. We have a test bed that is a stepping stone to the Arctic here, and we think it's a really excellent place to really sort out some of the pressing problems that are yet to be solved. We have a ideal shore facility where you are all invited here at the Great Lakes Research Center to participate. We have office space, we have lab space, we have a very modern boathouse, and we are right on the waterfront and in the center of a research-oriented campus. So it's a number of ideal conditions have come together to facilitate this development. We also have interesting shore geometry. We have a rocky coastline on our west side. We have a sandy beach more typical of East Coast shorelines on our east side. We have an urban waterway with harbors and obstructions left over from the copper mining days. So there are challenges right here that we think will push autonomy on the waterfront to new levels. We're also thrilled to have such good participation with all of you. As Andrew said, we'll put you to work later on, but that work is really to have you have a say on where we go in the future and to help us develop this concept across all of the Great Lakes with your guidance and experience. So thank you all for being here, and it's a pleasure to welcome you this morning.
Thank you, Guy. I'll also introduce Mr. Travis White. Travis will be talking a lot today, but Travis, if you just want to give a quick welcome and say hello.
Yeah, thanks, Guy and Andrew. Good morning, everyone. Welcome to all of you. Thank you very much for joining us today. We're very excited to have this virtual event, although we're much more looking forward to an in-person event next summer. Again, my name is Travis White. I'm a research engineer here at Michigan Tech's Great Lakes Research Center. And one of my roles here is helping to lead the Smart Ships Coalition administration, which includes organizing events like this and doing outreach to prospective and current members. So I'm sure many of you have already had some form of communication with me, and looking forward to a lot more of that. Smart Ships Coalition is an open industry group. Really, our goal is toward advancing maritime mobility. And we believe we can do that through very strong multi-sector collaboration. Meaning we've got participants in this group from government, international government organizations as well, academia, and all sorts of industry, which really gives us a lot of diversity here and a lot of perspective on the topics surrounding maritime mobility and smart shipping and marine autonomy. We're extremely pleased to have a growing membership. We're nearly at 60 different organizations right now, which spans almost 10 different countries. So our outreach has been great, and we're only looking forward to increasing that here with all of you. We welcome folks to invite others into the fold as as you're working and collaborating with different organizations that may have an interest in what we're working on here together. So we're pleased to have this audience today. We think this reflects the amount of interest and also the opportunity in front of us all here in the maritime realm, particularly with this growing topic of smart shipping and all the technologies that enable that. Really the goal of this event and future ones will be to begin having more dialogue among the various stakeholders in the organization. And part of that, again, is focusing on working group formation, where hopefully we can develop some strategies together and work on these various action plans together in the coming years. So I'm very excited about the roundtable discussions we'll be having on later in the workshop here today. But first, I have some really interesting presentations to share with all of you that highlight some of our recent and current activities relating to Smart Ships Coalition and in particular what we're doing here at the Marine Autonomy Research Site. As Guy mentioned, we launched Smart Ships as well as the Marine Autonomy Research Site in 2018 at the Great Lakes Research Center. And the research site, we'll call it MARS for short, is really functions as a test bed for new technologies. That ranges from hardware and sensors at a small level to full-scale unmanned vessels and vehicles, underwater as well, and even things like autonomous behavior development. So we have a lot of very talented science and engineering faculty here at Michigan Tech, as well as students from undergrad to graduate levels that participate in a lot of these projects that we work on. We see a tremendous amount of opportunity here in Michigan to make advances in smart shipping by leveraging the unique attributes of the Great Lakes. It's a very challenging environment. And we feel that a lot of that is supported by the strengths of all the surrounding industry that we have here as well. In addition, we like to bring a lot of our international partners into the fold here so that we can exchange information and lessons learned along the way with some of the folks that are leading in this area across the globe. The test bed that we have is open to everybody for use, and we would be happy to connect with any of your organizations to discuss this more. So if there is any interest and you learn more today about this, please reach out to myself or any of the folks here at the Great Lakes Research Center. But at this point, I'd like to kind of turn things over back to Dr. Andrew Bernard to talk about some of the exciting projects he's been working on here at the Mars testbed this past season.
Excellent. Thank you, Travis. And before I get started, just one more reminder. If you haven't already, I see a lot of people have, in the participants list, if you could go in and rename yourself and put your organization after your name so that everybody knows what organization everybody's with. You'll see mine as an example. I did Andrew Bernard-GLRC. To do that, you just hover the mouse over your name in the participants list, click more and rename, and you can add your organization. So we would appreciate that, and I'm sure the other members on the line here who don't know everybody would also appreciate that. So thank you. Okay, so thank you, Jackie. Yes, the slides are up. All right, so I'm going to start out with a little discussion here about some autonomy work that we've partnered with U.S. Geologic Survey and Pete Esselman in looking at how acoustic fish abundance estimates are biased when we use noise-producing vessels. And this is something we've known for a while, but it's been something that's been very hard to assess. But it turns out using autonomous vehicles that are extremely quiet, we actually have an opportunity to assess this now. And we've done this using a sail drone vehicle. Next slide, Jackie. So what we were looking at doing, if you look at the little image in the top right here, is when you use a large research vessel, and there's several of these on the Great Lakes that are either USGS operated, fisheries service, or state DNRs, that vessel creates noise, and the sheer presence of that vessel actually causes the fish to disperse. So the thing we're trying to use to measure to get a fisheries abundance of the entire Great Lakes, this huge system, it's actually changing the system itself as we're making that measurement. So the idea here is that by using a quiet sail drone vessel, this is a sail drone, is an 8-meter autonomous wind-powered vessel, we can actually get a better estimate using split beam sonar than we can with a large, noisy research ship. Now, there will still, of course, be reasons to use ships to do bottom trawls, to actually get hands on fish is extremely important. But to get a real abundance estimate over the whole lakes, maybe we can do better with autonomous vehicles. So this past August and September, we had 2 sail drones on Lake Michigan and Lake Huron. Those sail drones went 3,613 nautical miles in 45 days and took 24/7 observations. While they were out, we had 61 replicates where we had our traditional fisheries vessels run the same lines at the same time as the sail drone to get one-to-one comparisons of fish densities. And they also performed about midwater trawls in about 40 locations. So we have a whole bunch of data to look at now over the winter, which is great. As part of this, my piece of this was actually looking at the noise profiling of the sail drone versus the vessel. So for those of you who don't know my background, I'm an acoustics engineer. and I do a lot of underwater acoustics work. So this was a really cool opportunity to use that in conjunction with the fisheries community to look at abundance levels and we're going to try to correlate them to the noise of the vessels. So we'll go to the next slide here. We did Lake Michigan and Huron this year, and here you can see the tracks of the 2 sail drones in the 2 different colors. So huge swaths of area we covered. And then we plan next year to have those 2 sail drones in Lake Superior, and in 2023 to have them in the lower lakes, Erie and Ontario. So it's a 3-year project. We'll have all 5 lakes, and we'll have comparisons with the fisheries vessels on all those lakes. You know, the hope is that we show a much more accurate abundance calculation with these very quiet autonomous vessels. Next slide. So our objective at Michigan Tech was to develop this radiated acoustics test protocol for ships and deploy it and make it mobile, because we don't want to make all the ships come to us. We want to go to the ships. So you can sort of see a little layout here of what we did. We took our trailerable 24-foot fiberglass hull boat, and we are able to launch a bottom-mounted hydrophone array from the back of that is moored to the bottom, as well as a hydrophone array in the middle of the water column, and have the ships do pass-bys. So we've measured 5 ships so far this fall, and we'll have another 4 or 5 next spring. And then we also did the same thing with a sail drone off of the coast of Charlevoix in early September. So we have some noise measurements from the sail drone that I'll share here in a second. Next slide. So this is what our measurement setup looks like. This is testing in the Mars test site. You can see on the right of the aerial picture, I don't know if you guys can see my cursor or not. There you go. On the right of the aerial picture, you can see the Osprey with our bottom mounted array off the back. And then on the left is our research vessel Agassiz, which is doing an ROV inspection, and you can see our hydrophone array on the bottom. This is what we use to measure the noise of those autonomous vessels. And not only did we measure the sail drone, but we also have a wave glider here at the GLRC, and we've measured the noise profiles of that wave glider as well. Next slide. So here you can see a little summary of the vessels we've done and see pictures of them. They range anywhere from about an 8-foot long wave glider, which is the yellow device here in the second to the left, up to 100+ foot fisheries vessels. We measured the Kai in Lake Superior, the Arcticus and the Sturgeon in Lake Huron, and the Steelhead in Lake Michigan. Next slide. So this is what an acoustic signature of a ship looks like. And you can think of this kind of like a fingerprint. So every ship is different. If you look at these real quick, they all look kind of the same. But if you look at them in detail, you can tell they're all pretty different. So this actually allows us to identify different vessels and to quantify the noise on different vessels. And as we do more data processing, we'll get more into this and come up with one or a few numbers that signify the noise levels radiated from each vessel. And next slide, which I think is the last one. So this is a quick look because we really just got this data, but you can see on the upper left measurements from the sail drone, and on the right measurements from the RV Sturgeon is a representative louder vessel. So the main takeaway from these plots, if you look at the black versus the colored lines, the black lines are the background with no ship present. The colored lines are the noise with the ship present. You can see there's a pretty large noise profile from the traditional fisheries vessels. If you look at the top plot on the right, you can see there's a peak there that's almost 100 dB above the background. That's really loud. But if you look at the sail drone, you see those colored lines and the black lines completely overlap. So when we were out measuring the noise of the autonomous sail drone, we actually could not hear it above the ambient background, which is exactly what we want, because that then will not scare the fish away and cause them to scatter, which will change the fisheries abundance estimates. So initially, this looks really positive. We've got a lot of work to do. We're we're 1 year into a 3-year project, and actually we're only about 2 months into the data collection. So this is all hot off the presses, and we're excited to share it with you. Looking at a really unique application of autonomous vessels, and how they can potentially give us more accurate scientific data. So I think that's my last slide. Is that right, Jackie? Yep, perfect. Next, we're going to hear from Andy Zigweed, and he is the VP for Ocean Data at Saildrone. He's going to talk a little bit about what Saildrone is doing on the Great Lakes, this project and others. So Andy, if you're there, feel free to unmute and talk for about 5 minutes.
All right, thank you all. I appreciate the opportunity to speak with you today, and thank you, Andrew, for sharing a bit about that project. I figured the background noise would be low, and certainly, oops, I got slides here that I wanted to share real quick, just introducing Saildrone. So we're a U.S. business headquartered in Alameda, California, and we design and manufacture Saildrones. And our mission is to make the high resolution persistent ocean data collection cost effective at scale, in short. And as mentioned there, we've done considerable work with fisheries. Historically, we've sailed over 500,000 miles, circumnavigating Antarctica, conducting fish stock assessments, surveys with NOAA along the West Coast and in Alaska. We've crossed the Pacific and Atlantic Ocean basins and have done research in the Mediterranean as well. And proud to say that we've now conducted missions in the Great Lakes. So most of our work is ocean data collection, but we also perform maritime domain awareness missions and ocean mapping, which is something I wanted to bring to the community here as we look at both lake bed 2030 and mapping the world's oceans. So in addition to the fish characterization, our standard ocean data collections are all the mid-ocean parameters that you'd expect. But we can also do current studies as opposed to fish biomass with the acoustics. Again, here's some, just as Andrew displayed there, the vehicles are much quieter to get more accurate fish stock assessments. And now I'd like to just feature our mapping capabilities. The Surveyor was launched. This is a 72-foot Saildrone that can support full ocean depth mapping capabilities, or with an EM 2040 full lake bed mapping capabilities. So we'll have 3 vehicles available: the Explorer, the Voyager, and the Surveyor. And we look forward to helping map mapping the Great Lakes before 2030, and also supporting offshore wind. We can use our cameras to look at avian, birds and whales in the ocean, as well as wind speeds and any other mid-ocean parameters that are required for site assessments and characterizations. So thank you. I hope that's 5 minutes, and thank you for your time.
Yeah, that was perfect, Andy. Thank you very much. It's really been a pleasure to work with you guys. Okay, so our next talk will be Dr. Guy Meadows is going to talk about our switches project. Give us an update on that.
Great, thank you, Andrew. Now that you heard all the great work Andrew Bernard's doing, the bad news is we're losing him. He has been scooped up by Penn State University. It's a huge loss for us, but I would like to introduce Tim Havens, who will be taking over. Tim, would you want to say hi to everybody while I'm setting up here?
Absolutely. Hello, everybody. Welcome to the workshop. So great to see so many people online here. So I'm moving over from the College of Computing at Michigan Tech, where I'm currently Associate Dean for research. And then I'm also directing another institute at Michigan Tech, which is the Institute for Computing and Cyber Systems. And so in January, when Andrew leaves us for Penn State, I'll be moving into the directorship of the GLRC. I'm so very excited. The GLRC is such an amazing thing that's happening at Michigan Tech, and it's been great to be a part of it as a faculty member and researcher, and I'm really looking forward to being a part of it as director. So thanks, Guy. Thanks, Andrew.
Thank you, Tim. When you were seeing my slide, was it in presenter mode still?
Oh, we can see your whole screen right now.
All right, hang on. How's that look?
That's great.
Oh, super, good. Thank you for the opportunity here, and Tim, thanks for that great introduction. This project, which we call Switches, Seaworthiness Through Intelligent Trajectory Control, was one of the first real research projects conducted in the Marine Autonomy Research Site. The sponsor of this was DARPA on behalf of the Navy, and the question was, and is as the Navy explores more and more use of autonomous surface vessels, eventually they get trapped in large sea states, which causes them to not be able to complete their mission. And that typically drags the mothership off of its mission. Recovering the ducklings in large sea states is usually a catastrophic disaster. So there's been a number of losses of autonomous small surface vessels by the Navy. So the project is there an intelligent trajectory through large wave states that would allow these vessels to at least complete their mission, and if that's not possible, at least survive the conditions to be able to work another day. So the Marine Autonomy Research Site was an ideal test bed in scale for large open ocean wave conditions. The Autonomy Research Site is roughly a 30 nautical mile circle around the center campus, the waterfront location of the Great Lakes Research Center, and encompasses both of those shorelines that I talked about, the rocky West Coast type shoreline and the sandy East Coast similar shoreline with the urban harbor in the center. There are also two mid-ocean buoys, one on each side, that provide direct observations of those conditions around the site, and all that data is instantly available to the general public and any of the participants in the Mars setup. So this was a large program, as I say, for DARPA. We're only going to talk about the highlighted field data collection portion, but there is a dynamic survivability component, a vessel simulation, wave vessel dynamics part, and then the actual optimization of the path through evolving real-time wave fields. We are very fortunate to have, as I mentioned earlier, tremendous collaboration with the Coast Guard. The Coast Guards are the world's expert in maneuvering small craft in large sea states. There's an entire multi-year course that the surf boat operators go through. The senior chief of our station here is a certified surf boat instructor, and we're one of the few stations on the Great Lakes that have 47 motor lifeboats, the surf boats that the Coast Guard uses. So it was a tremendous marriage there to be able to pick their brains and actually obtain this tremendous capability of maneuvering in large sea states. So our test vessel just happened to be the one that best fits the hull characteristics of the Navy autonomous fleet. It happened to be the top of the line Wave Runner by Yamaha. It has a length to beam ratio of 3:1, just as the Navy 11-meter rigid hull inflatable boats. So it was a very nice hydrodynamic comparison with the Navy boats. And again, it was at about 1/3 scale. In fact, very close to exactly 1/3 scale model. So wave fields map linearly with scale factor. So a 3-foot wave in Lake Superior is equivalent to a 9-foot wave with the Navy full scale boats. We fully instrumented this jet ski with a whole variety of instrumentation, including dual high definition stereo vision, real-time transmission to shore, a full 6 degree of freedom motion package. So the detailed vessel motions were recorded at very high frequency. Inertial navigation system, and then we had it operated by Senior Chief Myers from our station here in the Portage Waterway. There's also a 360-degree camera on board. We then instrumented more wave sensing equipment out in to the north side of our test facility on the Mars side. So just out of the picture in the upper diagram here, if you can see my cursor, we set an array of 4 additional wave sensors, and then just off the view is the permanent Met Ocean Station, which provided a really nice opportunity to record the wave conditions. The triangular pattern of the wave sensors corresponds with the triangular marking of the course, and I'll talk about that next. The ConOps, concepts of operation during the experiment, were to have the senior chief drive the vessel with the simple stupid course, that is from point A to B to C and back again in a straight line, and then immediately repeat that with the wave dodging course, which is in the blue lines. And then that procedure was repeated continuously over a 2-day period. So we certainly got a tired senior chief out of the final process. But we acquired tremendous data. If direct your attention over here. So to match the straight line course are the red motions. This is roll and pitch and yaw of the vessel. So the red lines are the straight simple course. The blue lines are the wave dodging course. The concept employed by the Coast Guard in their wave dodging surfboat manual is, at all costs, you want to minimize pitch of the vessel, because as pitch increases, eventually you reach a condition where your propulsors and your rudder are out of the water. You then lose control, turn sideways in the wave, and bad things happen. So at all costs, you want to minimize pitch. And to do that, you will see that they sacrifice roll. So roll, the blue lines during the wave dodging course are increased over the red lines. So roll has increased up to 20 degrees of roll for this particular vessel. But if you notice the second diagram in pitch being, again, the blue lines for the wave dodging course, are significantly less than during the straight line course. So the goal is to minimize pitch, and that is achieved. The lower diagram is yaw, so you see the 3 general courses, upwind, crosswind, and downwind type of course, so that we get all the dynamics of the vessel with respect to sea state and heading. If we look to the accelerations, top line is heave, which is the up and down acceleration. The second line is surge, which is forward backwards accelerations, and again yaw for the 3 different legs of the course. So again, with the wave dodging course, the blue, we minimize heave accelerations, up and down accelerations, and we have minimized surging accelerations too, compared to the straight line course. And putting that perhaps in a more understandable framework, these first 2 diagrams are the amount of pitch for the straight line course here, and for the wave dodging course here. So we have eliminated all of the high pitch angle experiences. So we top out at about 11 degrees of pitch when doing wave dodging, as opposed to 15 to 16 degrees of pitch doing the straight line course. Similarly, if we look at the acceleration, slamming in particular, which is a huge problem for the Navy. Apparently, their small boat drivers, when delivering folks to a landing on a beach, only know 2 speeds, full out and off, and slamming accelerations in excess of 1.5 Gs are very common and result in injuries of the people being delivered to the beach. So again, with the wave dodging, slamming is reduced to about 1.15 Gs. So all the big slamming events are also eliminated. So in all, we collected 12 sets of data over a 2-day period, comparing the straight line course with the wave dodging course. The vessel motions in straight line wave dodging mode were compared. Wave dodging allows for larger roll, but to minimize pitch, this prevents loss of propulsion and thus loss of control. And these observations have impact on both vessel design and autonomous control. So again, as we move to more and more autonomous vessels, eventually they will be getting into situations that are beyond their design characteristics in terms of wave conditions, and calling them back or rescuing them is usually not an option. So again, thank you very much, and I think we'll have time for questions later in the presentation, but I sure appreciate your interest.
Thanks, Guy. Yeah, and a quick note, we will have a nice Q&A session here right after the next couple presentations. So anyone that's got thoughts on any of these presentations, please jot those down. We're looking forward to them. Let's see here. I'll share the next presentation. Okay. Thank you, everyone. I'm going to give a quick update on a couple of interesting projects I've been working on here at the Mars test bed. We've got a project called CMAP, which stands for Shallow Water Environmental Assessment and Multi-Beam Autonomous Platform. It's kind of a long acronym, but what we're doing since kind of transitioning past the DARPA work with this jet ski, we're building out the autonomy on this vessel now. And one of the goals is to be able to use this platform as a highly portable, very easy to operate autonomous surface vessel that can be trailered anywhere around the Great Lakes or even outside of this area and deployed by 1, maybe 2 operators, with the goal of having it equipped with some of the sonar instrumentation that will help contribute to mapping the Great Lakes. In particular, with this asset being a jet ski, it's very well suited to getting into those very shallow, marshy, estuary type environments where conventional surveying vessels and methods are not necessarily efficient or practical. So we'll have an instrument mount on the back of this vessel here with a telescoping arm that will actually deploy the sonar head. If we're in very shallow water, just a few inches down, and deeper water a little bit further below the vessel hull to get out of the interference. So to kind of give a little bit of an overview here, as we develop the autonomous controls in this vessel, which we're currently in the process of finishing up, we've actually taken and adapted controls from the unmanned aerial vehicle industry to this vessel in order to create an autonomous surface vessel autopilot system. So one of the things that we're really, I guess you could say, geeked about here at the research center and the test site is looking at existing technology and figuring out different ways of applying those, sometimes in very completely different domains. As is one of the goals of Smart Ships, being based in Michigan here, we've got a very robust automotive industry where there's a lot going on in the areas of electrification as well as autonomy. And one of the high level concepts of operations, looking at how can we take some of these different technologies that are being developed and transition those cross domains. So this project sort of encompasses just that, taking sort of the UAV drone flight controls and adapting that to a vessel. One of the things we're excited about in having this project completed is having a sort of a hands-on platform that our students can interact with. This is something that will be incorporated into a lot of lab and coursework at Michigan Tech. So this gives undergraduate and even graduate level students an opportunity to actually experience operating and deploying an autonomous vessel, as well as coming up with projects out on the lakes that they can use this tool, whether it's collecting scientific data, basic ocean science, limnology, biology. There's a lot of different ways that we can outfit sensors and instrumentation onto this platform. So one of the design concepts here was to keep this very modular and something that can easily be added on to. In addition, having this asset here at the Mars test bed will allow us to work on different sensor and payload testing, and this is another autonomous platform that partners and collaborators can come here and use if they have technologies or piece parts that they'd like to field. So a quick snapshot here, just giving you all an idea of what the operator interface will look like, and also what some of the hardware that looks like that we've adapted from the unmanned aerial vehicle supplier. So we've got a couple of these small black boxes down at the bottom and a joystick interface. These black boxes are really a matter of roughly 2 inches by 2 inches. So they're very small hardware packages. As you can imagine, they're being put on drones, which can't take a lot of weight up. So we've been able to take this very small off-the-shelf hardware and package it into the jet ski, working with Yamaha to kind of interface to the throttle, and we've adapted a linear actuator to sort of replicate the steering. And the final product will give us the ability to do point-to-point navigation. The vehicle will be able to loiter. We'll be able to send it out into the lake at times of the year where our vessels aren't operating or they're laid up for winter. And we'll be able to collect some interesting scientific data during these sort of fringe seasons. So it's a very exciting tool to have here. Basically, all of the autonomy hardware is now fully integrated, and we're right at the point now of doing the final gains adjustments to get this vessel operating smoothly. And then to touch a little bit on how we intend to use this for shallow water mapping. Here's sort of an example of one of the multi-beam sonar heads that exist. That it's very small and compact. It's not very power intensive. And for these shallow water zones, we don't need a very powerful sonar head to reach down, hundreds of feet. So it's something like this can be deployed off of the small jet ski and give us very high resolution mapping of these shallow water areas. One of the things with the jet ski is it's got a pretty significant cruising range. So when we fill the tank of gas, we can go about 140 miles at 3 knots to be able to perform these surveys. So that gives a lot of persistence to this. We can deploy it, create a mission plan, and have it operating continuously for a great amount of time. And as many folks here are aware, classic applications for autonomy are dull, dangerous, and dirty. So if anybody has ever been involved in surveying or bathymetric scanning, there's a lot of repetitive, we call it mowing the grass. So you go back and forth. So being able to program this vessel to do that for us, and then having an operator like myself essentially controlling it, monitoring it remotely through a control center here at the research center, really increases sort of the efficiency of how we can operate this type of survey. And then last, I'd like to touch on an exciting project that we're working on here in partnership with one of the Smart Ships Coalition members, DocTech. They're based out of Israel, and they have a hardware package that interfaces very easily to commercial sonar and GPS units. So in the bottom right, you can see a picture of, we'll call it the black box that plugs into the sonar and GPS data on many very popular sounders. So what that black box does is it sort of logs the vessel, similar to a black box in an airplane. It logs that flight data, it logs the vessel data as it transits. And in areas where you've got many vessels with this type of equipment, it's logging that bathymetric data from all the different vessels and creating these very high resolution, very dense maps showing basically your waterway, the bottom, the depth of water, obstructions. And what's really interesting is with this sort of real-time data collection, and as your network of vessels using this system increases, you can really, you're able to monitor things in real time to see how those waterways are changing, whether it's natural waterway fluctuations or perhaps it's new obstructions. This system really gives that ability to kind of go back over time and see those changes. And why this data is useful, as many of the audience here is aware, this waterway data is significantly important for commercial uses, whether it's optimizing your cargo loading, your path planning, your mooring arrangements. And also it helps our operators and maintainers of these waterways to sort of figure out where the maintenance is needed, whether it be dredging or creating different access points to some of the ports of entry. So we're excited to be deploying this here and testing it. And one of our hopes is that we can help DocTech find some commercial uses here in the United States by demonstrating the value of this tool and how easily it interfaces to these vessels, and help them find various use cases where this would be a benefit to industry. So we'll continue to, we just got this equipment here at the research center. We're getting it on our vessel as we speak. And we'll be doing sort of this mapping of the Mars test bed. So we've got a waterway between the upper and lower entrance of Portage Canal. It's about 20 miles long. And this hardware is going on to our research vessel, which transits this water frequently for everything from class trips with students to research projects out on the big lake. So we'll, over time, be able to create this type of high resolution map of the waterway. And of course, another great use for that is we're bringing more and more autonomous vessels here, is having this data set that can be sort of interpreted by the autonomous vessels and their control systems, so that we can really plan out safe paths for navigation for these types of vehicles within the test bed here. And with that, I guess lastly, we'll plan to share this data with a wide range of users. So that would include recreational users, our local municipalities, the Lake Bed 2030 effort. So that's one of the great things by collecting all of this data and having it available. It benefits the whole maritime community here. And kind of highlighted in red there, that's DocTech's leading question is, what if we could harvest data from every vessel in the world? What could we do with it? So I'd like to kind of conclude on that thought. And if anybody has any interest in this hardware or this project, please contact me and we can certainly share some more information. And up next, I'd like to introduce Tim Havens again, and he'll be talking about machine learning, artificial intelligence, and cybersecurity in the maritime domain.
Thanks, Travis. Great presentation. It's just really exciting to see the resources that are being built up in the Mars site. And it just inspires me with so many ideas for proposals and collaborations every time I think about it. Okay, so I thought that I would, can you see my screen?
Yep.
Okay, wonderful. I thought that I'd introduce my research because I know I haven't had a chance to talk to a lot of you in the past. And so just to give you an understanding of kind of where I'm coming from. So currently I'm a professor in computer science at Michigan Tech, and then also the associate dean, as I said, for research in the College of Computing. So I like to say I went from thinking about my research program to thinking a lot about other people's research programs. And, I'll carry that on as take the leadership role at the GLRC. But over the last about 10 years, I've been a professor at Tech. I started as assistant professor in 2012. Before that, I was a postdoc at Michigan State and did a lot of artificial intelligence research there. And then if I go really far back in time, I went to Michigan Tech as a student, always wanted to come back. And after that, I went to MIT Lincoln Labs and did a lot of Air Force research, specifically a lot of radar signal processing and adaptive optics research, which of course both are of big interest to the Navy, and radars are something, one of the sensors that we use in autonomy. But just kind of to look at what I do in my lab. So I run the Pattern Recognition and Intelligent Machines Engineering Lab, the PRIME Lab. I of course came up with the acronym before coming up with the name of the lab, because that's the most important piece. We do a lot of feature and sensor fusion, so combining together different sorts of information from different types of sensors, or even different information sources, such as things like text, tweets, user input. We do some human-assisted machine learning. And so on the left there, I'm just showing an example of some of the work I've done with the Army. I like to show this picture because the sensor fusion is pretty obvious. It's pretty ridiculous, in fact. I like to call this the kitchen sink sensor. It has two radars. You can see the horizontal plates and the vertical plates. Those are two different polarizations of forward-looking radar. You can see the LiDAR up on the top left of that array, like that top hat thing that you see on all the self-driving cars these days. There's a high frequency radar on top of that, which looks like those little spotlights. There's differential GPS, there's LiDAR. I already mentioned that. And then also communications in order to look at these data in real time. And so we've worked for a very long time on helping the Army figure out how to find hazards in the road and not drive over them. And so you can imagine what those might be. And it's a difficult problem because it's fairly easy to find hazards right when you're over the top of them. And I don't mean that in a glib sense. I mean that if you can aim your sensor down straight into the ground, it's very easy to find something there, but it's also too late. So we've been working on moving that detection forward. And I can imagine, this being very applicable to looking at things like what Guy Meadows was talking about with regard to looking at sea state with the autonomous jet ski. I do a lot of signal processing research. So kind of bridging both my history at Lincoln Labs, which was, what I like to call fundamental statistical signal processing, or all the people that do this research kind of look at machine learning with a little bit of a disbelief because they think that everything should be in optimal statistics. And so what I'm showing there is just some algorithms that we've built to produce better images using radars. And lately, Dr. Bernard and I have been working together on applying some of these techniques together with acoustics and looking at finding objects that are under and on the ice using acoustic vector sensors. Some things that I've been I would like to say dabbling with is this disruptive future technology. And this kind of comes just from, I have a passion for RF arrays. And so I've been working with MIT Lincoln Labs to develop full duplex RF arrays. So arrays that can simultaneously transmit and receive so that you can get both more power on target to improve signal to noise ratio. And then at the same time, if you think about two of these in communications, you can have full duplex communications. And so that's a difficult problem because now you have to extract both the transmitted and received energy at the same time. So that's just a little intro into kind of where I'm coming from. But thinking about the autonomy of boats and marine systems. So I thought I'd put this chart up there just to kind of bring it back to what is autonomy in a marine system. And so Lloyd's Register has autonomy levels, and so these are very, very similar to the autonomy levels that you might have seen in the news for self-driving cars, although there are only 5 of those for self-driving cars, and we have 6 because marine autonomy is much more difficult. Everybody likes to say, oh yeah, autonomous boats, that seems easy, there's nothing to hit. Okay, they don't understand the water. Driving a car on the road is so much easier than marine autonomy. So we can go from the left with just no autonomy of manual operation, and then going all the way to the right to that truly unmanned crew optional autonomy level. And I like to think of these autonomy levels with the more descriptive language of going up to AL2. It's the hands-on autonomy. It's the things that are helping you drive the boat, make decisions, but you are still making all the decisions that go into the control systems or that make that system move and do its operation. Getting into conditional automation is that hands-off automation. So now you can take your hands off the wheel or the helm, as it may be, but at the same time, you still have to be there and ready to take control at any moment. High automation is the eyes-off automation. So at this point, you might be able to watch a movie while you're doing this, or do another operation in the marine system. With full automation is the mind-off automation. So this is, you can, oh, sorry about that. There's somebody just came in my house. It's being handled. The AL5 is mind off. You can completely forget about it. It's going to work, but you're still there. And then finally, the crew optional. And AI and machine learning are used at every level of these autonomy at this point in order to produce better autonomous systems. And as you can see in that image there, I think of marine autonomy more than just the things that are happening in the water, on top of the water, under the water, but also the associated systems with that. The drones that are used to look from above, the satellites that are used for communications and looking from above as well. And then also the terrestrial autonomy that these systems work with. And so looking at ML AI in marine autonomy, I categorize these in 4 big groups. So predictions from big data. So this is where the autonomous systems are used to collect data that might be impossible or infeasible with manned or remotely controlled systems. So you can send out a swarm of vessels. They can collect data always because they can have long duration missions. And then those data can be used with machine learning and AI in order to make better inferences about what's happening in the world. So here I'm showing, a wave glider that we've deployed here at Michigan Tech to take measurements like nitrogen and oxygen levels in the water. And then also an image looking at water surface temperature throughout the Great Lakes, for example, like the work that Dr. Pengfei Zhu is doing at Michigan Tech. Moving to AI assistive technology, this is now where you have AI systems that allow the human operators to focus on things that humans do best. So the critical decisions as opposed to the repetitive, tedious, or even hazardous decisions. Furthermore, AI systems can always be on and they don't get tired. So you can have things like collision avoidance systems, like I'm showing in that image there, which allows the vessels to see objects that might be coming into their path. Classical mobile autonomy is all the things that you would find at a conference like ICRA or IROS. It's the SLAM, the simultaneous localization and mapping, sensing, localizing, path planning, and navigating. So I would categorize Dr. Meadows' project with the jet ski as exactly this. It's trying to develop a system that can autonomously navigate through high seas. And then finally, something that I'm really interested in, work with the Army quite a bit on, is adversarial AI and cybersecurity. So thinking about autonomous systems, that they must be resilient to sensor perturbations, malfunctions, and also bad actors. There are going to be people out there that try to confuse autonomous systems for various reasons, and we need to create robust autonomy to be able to account for that. And so I just kind of wanted to go into a little bit of detail about the work that I've been doing with the Army in that lower right quadrant there on adversarial AI and cybersecurity. So here's kind of how we think about that area is in spectrums. So the types of attacks going from jamming attacks, which are just, can we render a sensor useless, shine a bright light at the camera, point your laser pen into a LiDAR, to concealing attacks, which are, could we perhaps put something on a boat such that it can't be seen by a system, such that a collision avoidance system no longer works. To spoofing attacks, which of course could be very devastating, where maybe this is we're able to produce readings in an autonomous system that makes it think where it's somewhere where it isn't, and thus it runs aground or something like that. And then we characterize attacks as deception level, detection capability. So these are kind of related. How deceiving are they? Can they be detected easily? The intel box level, how much do you need to know about an autonomous system before you can actually implement an attack against that system or perturb its sensors? And then the damage level on that attack. And then so we kind of tie those all together into what we call an attack risk, which combines the attack likelihood. How likely is it that this is going to happen versus with that damage tied together. And then finally, we come back and we think about these as how can we mitigate these? So I think this whole red team, blue team cycle and look at the capability and the complexity of attacks and then tie this together into overall risks. And so we do a lot of work with Army mobile systems to go through this whole process with them on various things. And so I'm just going to show some examples. This shows how we use simulation and robot operating system to look at how systems might react to certain adversarial perturbations. So here I'm showing just a block diagram going from a simulation product we use called AirSim, which I'll show next. We produce then simulated codes for adversarial lasers here that ties together with the robot operating system. I'm showing an image of what those dazzled images might look like with a laser, how that might corrupt point clouds from a LiDAR, and then those go to the downstream autonomy processing nodes to evaluate what happens. So here's an example. So on the left, this shows our simulation environment, and this isn't the simulation environment we use, but it shows this pretty well. So it's the exact same software we use, just different. We somewhat like this, but I actually can't show it. So I'm showing this one. This is AirSim with the Unreal Engine. So if you've heard of the Unreal Engine, you might have heard of it in the terms of a gaming engine, and that's exactly what it is. It produces physically real enough simulated, what we call photorealistic environments that you can then move robot models through. And so what I'm showing there is an image, and then the 3 sub-images show the different sensors that would be used by a mobile autonomous system, including a depth sensor in the lower left, a segmented image in the lower middle, and then that RGB camera image on the lower right. So what we do is we take those sensed images, and so those 4 images I'm showing there, those are depth sensor images, which you might get out of like a stereo pair of cameras or a LiDAR, and we perturb them, and then we run our robot through various courses to see how they react with these perturbed sensors. And so just as an example, I'm showing 2 paths in the lower right, an unperturbed path. You can see what the robot was tasked to do is to navigate from the left to the right, going from a start point to an end point and get around the obstacle while doing that. And you can see with unperturbed depth sensors, it does a great job, and it does it near consistently every time. Where with perturbation, you can see that the robot starts to act a little bit more strangely. Although what I'm showing you here is after we've already robustified it to one of the attacks that we produced. And so you can see while the robot takes a little longer to get there, it does get there just about every time. And so the reason I bring this up is that a challenge in autonomy is expense, time, complexity, dollars, and this is certainly the case with marine autonomy, where experiments are much more difficult than just running around a Pioneer in the lab. So one of the things that I would like to look at in the future is to develop a physically real enough simulation of Mars so that we have both the in silico Mars and the in situ Mars, to perform in silico experiments with the various platforms that we have at the GLRC. Then we can go out and do validation experiments in situ in the actual environment. So that kind of ends my portion of this. We're going to move on to a Q&A now. And so feel free to pipe up, ask any questions of any of the presenters, and then we'll take a little break after that. So so everybody can refill coffee or whatever you need to do at that time.
Good morning, everyone. It's Howard Posens from Transport Canada Innovation Center. Could I get more information on Lakebed 2030? What's the purpose and who are the participants? Thank you.
Guy, you want to take this one?
Oh,
Travis?
I was hoping you would. Okay. So Lakebed 2030 is being driven primarily by the U.S. Geologic Survey. It is a piggyback on Ocean 2030. The recognition is that large parts of the Great Lakes have not been surveyed to modern standards. Some of the surveys are up to 100 years old. The goal is not only to do depth surveys, bathymetric surveys, but to also do habitat surveys and assessment of bottom conditions. So it requires advanced sonar systems. The price tag is quite enormous. There's no funding identity thus defined. But again, the goal is to try and have the Great Lakes resurveyed by 2030. Who knows if we'll make that, but it's certainly, given the number of available survey vessels, it's certainly not going to happen successfully with human occupied crews. There's going to be a large component of that that's going to have to be done both remotely as well as with autonomous types vessels. And that has been a big driver for us to try and push this technology forward.
So my follow-on question, has the Canadian Hydrographic Service interested or are participating or been contacted on that?
Yes, they are. Yeah, the answer is yes to all three. They have been active participants. They are strongly engaged with this, and it is a binational effort across the Great Lakes.
Last question, is it possible to get the contact, the Canadian Hydrographic Service contact, so that I
Yes.
can speak to them? Thank you.
Certainly, we'll get that to you. We'll look it up. And I just want to note that we have, in watching AIS across the Lake Superior waterfront, we have noticed that there's been 2 or 3 survey missions conducted by Canadian autonomous vessels, lasting several weeks to a month in duration. So Canada is very much engaged in this, and from our conversations with the governors and premiers, and would somebody from governors premiers want to comment on Canadian participation?
This is David Knapsker. We've been coordinating, of course, with the provincial staff from Ontario and Quebec. We've also had a number of contacts with your colleagues at Transport Canada. Pleased to have your involvement with the Smart Ships Coalition and would welcome future opportunities to talk with you.
Excellent. Thank you very much. I appreciate the information.
Thank you, Howard.
And this is David Knapsker again. I'll ask a question, perhaps for Travis. I'm interested in how you are approaching your thinking at the Great Lakes Research Center and with the Smart Ships Coalition. Really enjoyed the presentations. You're doing some very interesting things. Are you primarily looking to external entities that are looking to partner and test with you, or are you kind of imagining things that you think could be interesting and looking proactively for partners. I'm wondering specifically when you talked about the lake bed mapping opportunities with vessels that are trafficking the lakes, and what if we had a sensor on every ship, for example? What if we thought about the commercial ships for just one subset of that universe, and what maybe we could do with that? So if you could just talk a little bit about your kind of creative process and perhaps a few of the ideas maybe that you're developing.
Yeah, thanks, David. That's a great question. Our goal is definitely bigger, as you suggested, in bringing this industry group together and trying to figure out where a lot of our respective organizations have overlapping interest. And one of the hopes is as we form these working groups and we start to really get that active exchange of dialogue and hearing ideas from different organizations about what's impacting them, what might be coming down the pike in terms of regulatory challenges and obstacles, or even just things like that. How can we get a certain technology out that's going to benefit the whole industry? Our hope is to let the Smart Ships Coalition be largely industry-led, or not just industry, but participant-led. And I think that's really where, as we get into the working group conversations, we're hoping to see that sort of take shape. Certainly as a partner in Smart Ships, Michigan Tech is happy to support, with testing and things that we can offer in terms of our services here, and the great assets we have with the Lake Superior test bed. But we very much want to see this group be member-led so that we can kind of find these goals that everybody has in common and work as a coalition to address those.
Great. So what I'm hearing is if people have good ideas, they should approach you with them, and you're doing the same with them.
Absolutely. Yeah. I think, we feel here at Michigan Tech, we feel the best way to advance maritime mobility in general is to have everybody actively participating and, knocking down the barriers together. So that's our goal.
Terrific. Thank you.
Yeah. Thank you for the question.
Chris, I see you have your hand up.
Yeah, great presentation. I'm looking forward to the rest of the morning here. Chris Burns from Mackinac County, home of Mackinac Island, and hundreds of ferry boat trips a day. And so we're excited to be working with Michigan Tech already on the potential to electrify those diesel ferry boats. As well as the potential to generate some hydropower from the deep straits. So we're very excited about that. And so what I'm hearing here is that there's potential to look at the automation of those ships. With that many ferries and that many movements a day, seems like we'd be a great test case. They're just doing the same route over and over and over again. It's my job to go get the money to do this sort of work. So I'd love to launch that with you guys, get some funding to automate our ferry boat motions and actions here. It would be a tremendous project for us. And interestingly enough, would be a huge economic development boom for us as well, because those seasonal jobs are actually sort of hurting our economy, because those folks then don't have a job half the year, and we're trying to create more year-round jobs, and the ferry boat operators are not happy with me trying to create those year-round jobs because it makes it harder for them to just hire those people seasonally. And so so being able to automate those seasonal positions on those boats would be just a terrific idea for us. So I'm very excited about working with you guys. Would love to chat as soon as we can about that with Doc Tech and you guys at Michigan Tech and so forth, for the potential to do that, because there's lots of funding available for this type of work right now, and that's my job to go get that money. So just excited, really glad you guys put this program on here today, and looking forward to working further on that.
Yeah, thanks, Chris. We're happy to have you, and I guess maybe also point out another great thing that we hope that comes to Smart Ships Coalition is the opportunity to network with all the various participants, including industry groups here that have some of those technology solutions that you guys might need to implement in some of these exciting projects you've got going on.
if I could add one thing to Chris's comments, and that is the other thing that is happening in the Straits of Mackinac is we are going fully operational with our high frequency current mapping radars. So starting very soon, for the next few weeks, we will have surface current maps once an hour for the region from the Mackinac Bridge to the west. And again, if for search and recovery types of operations, we hope that will become the standard go-to place. We hope, and since Chris, you're in the business of finding money, we're hoping that we could put another pair of radars looking east to cover the region, Mackinac Island and Bois Blanc that way. So we hope this technology will be useful for a number of purposes, as well as providing it to the vessel captains in terms of some of the strong currents that develop in your region.
I think we've got time for maybe one more question. And after that, if we missed anyone's questions, please share those in the chat. We'll try to follow up with you after the fact. But let's take one more question if there's one, and then we'll take about a 3 or 4 minute break before we start our next presentation.
I've got a separate question, if that's okay. It's really cool to see the work you guys are doing on the optimal routes and so forth. And I'm just curious if you foresee any work on in that area if the vehicle happens to be sail driven, because it seems like a lot of the work had to do with keeping the propeller in the water. And if you're not being driven that by a propeller, it seems as though you got a whole different set of dynamics and so forth. I'm just curious if that might be the future of that work.
Andrew Zigwe, do you want to comment on sail drone? You just successfully sailed through a hurricane.
Sorry, there had to unmute. No, I appreciate that. That's a really interesting, question. The methods Guy used, I'm certainly familiar with in my former role with work class ASVs. It's really important to keep that prop in the water, absolutely, and get a good course. And payloads, the effect on payloads also matters when you're looking at roll and pitch. And the same goes for any vehicle. Our sail drones are wave piercing to a degree. And part of our autonomy in-house is that path planning through the wave states as well. So we have not worked collaboratively yet with MTU on that. There's various methods in addition to the stereo cameras that can be looked at, but we're certainly monitoring the wave height and period while we're underway to determine the best path on our missions. I don't know if that answers the question, but I comment there.
Thanks, Andy. Yeah, that's great. And Chris, great question. All right, welcome back, everyone. We'll give it just another minute here. And we've got Emily Fennell from Eagle and the Office of the Great Lakes up next. So we'll give it a minute. And Emily, whenever you're ready, you can have at it.
Sounds good. Can you hear me okay? I just put my earbuds in.
Yeah, sounds great.
Good.
We've got 9:25, so yeah, feel free
Go
to
ahead.
take it away.
All right. Well, I'm excited to be here today, even though it's virtual, with so many industry and government and academic partners that really share a common interest to help us advance the application of autonomous technologies, particularly in the Great Lakes region. I'm Emily Fennell. I'm the Great Lakes Senior Advisor and Strategist with the Office of the Great Lakes, which is part of the Department of Environment, Great Lakes, and Energy. It's kind of a mouthful. But we're really pleased to continue collaboration with the GLRC to build on the successes that have been achieved thus far with the Smart Ships Coalition since 2018. And we're proud to have been one of the original co-sponsors of this effort. So it's exciting to be here today and hear all the great innovations that have happened and some of the research, and looking forward to working with the new GLRC director. Andrew, we'll be missing you, but wish you the best as you move to Penn State. So being an MSU fan, we'll look forward to playing you in future football games. One of the things that I have been very excited about in the last couple of years and the work with the Smart Ships Coalition is the opportunity for us to really focus on some of the greater synergies between this work and the state of Michigan's goals to help put the state on a path to achieve carbon neutrality by 2050 and address mobility challenges. So the SSC and Mars are an example of, where I see a lot of strategic integration of multiple priorities for EAGLE, for the Office of the Great Lakes and the state of Michigan to help us address climate, energy, and mobility challenges in the Great Lakes region through innovative maritime solutions, particularly related to water technologies. So this work really sits at the intersection of several state of Michigan goals and priorities. It provides benefits for Great Lakes science and research and the maritime industry, helping us continue to grow Michigan and the Great Lakes region's blue economy. It's helping us advance those Great Lakes science and research needs through more systematic data collection, which helps support more informed management decisions. And one of the areas that we've been particularly interested in through the Office of the Great Lakes, we've had a longstanding close relationship with our water centers and our research centers through all of our universities across the state of Michigan. And we see this as a great opportunity to really harness the suite of assets and intellectual capabilities of these water and research centers, as well as the connection with our community colleges. This helps us build some robust public and private partnerships and link innovation, research, development, and entrepreneurialism. One of the areas that we're also particularly interested in from the Office of the Great Lakes and state of Michigan's perspective is the ways that the GLRC is helping to advance some priority objectives tied to STEM education. So we heard a little bit from you, Travis, today talking about some of the great work that you're involved in, some of the specific projects. But the work that the GLRC is doing is helping to advance STEM education, including promoting water stewardship, helping to provide high quality educational opportunities, and building that inclusive STEM workforce that's really important to the state. So we see some great synergies with tying that STEM education and the innovation, talent development, and research, really helping us focus on solving some of these critical water challenges, particularly in areas where we can create new jobs for Great Lakes scientific research, both in the shipping, manufacturing, and maritime space. So we're happy this year to be able to provide some additional support through the Office of Great Lakes, through the Michigan Great Lakes Protection Fund, which we administer. And we've been working closely with Michigan Tech and several state agencies, including our partners through MEDC, who we'll be hearing a little bit more about after my remarks, as well as the Department of Natural Resources and Department of Transportation. So I know I have a number of my colleagues here from our work group that have been working closely with you, Travis and Guy and Andrew, over the last several months. And we've been talking about, an implementation strategy that helps us really advance Michigan and the Great Lakes region as a national leader in maritime autonomous technology research and development. So we've had some opportunities in the last several months to talk about some specific next steps to help us really advance some of those emerging opportunities. Getting into the details of things we've been hearing about already this morning, dealing with the applications of marine autonomy for fish monitoring, the bottomland survey work. I remember when I started with the Office of Great Lakes a number of decades ago, I won't name how many, and we were supporting some work with the Great Lakes Research Center and NOAA down in Ann Arbor to do some mapping work of the Great Lakes. So it's interesting to see that come for full circle now, and looking at the opportunities where this autonomous technology can help us have some better data and understanding the overall bathymetry of the lakes. And then we see some connections with climate and carbon neutrality goals. There's huge efforts going on at the state of Michigan. Obviously, some of you may have heard about the work that we're doing with the Council on Climate Solutions. And I know my colleague Julie Stavelin is here with us today from our energy and sustainability programs and climate programs. So a lot of work happening in that space. And then some tremendous funding available to support economic development, and also look at some of the public health and safety issues. One of the things we deal with in the Office of Great Lakes and EAGLE is helping to improve public safety in the Great Lakes through and dealing with maritime hazards and beach hazards. So as part of this effort, the Office of Great Lakes is providing some additional funding to support the phase 2 work for the GLRC so that they can continue to provide leadership for the Smart Ships Coalition to help strategically grow and make progress towards the long-term business plan and work plan that's already been laid out. So, as Andrew was saying earlier, we're really excited for the workshop today to help us start to lay the groundwork for future growth of SSC and Mars. So some of the funding that we're using to support the effort is supporting this, this workshop that we're having today. It will also help support the development of a longer-term sustainability plan for SSC and Mars. And we're looking forward to the work group discussions today that will help us start to flesh out what are the common issues and challenges from the different members and interested stakeholders, and how do we start to collaborate together to develop some action plans and strategic projects to move those forward. And it's just, I think, an endless opportunity that exists ahead of us and lots of great ideas that are just coming out of the discussions this morning. So looking forward to the breakouts a little later on this morning. And then the sustainability plan will, be informed by the members of this group and stakeholders, and really help define sort of the future of the SSC and Mars, and looking at the value proposition of the different areas that we can add some value and create some synergies and really drive some progress forward. So we're looking forward to the discussions today. We can't wait to be in person, hopefully with all of you in the summer. I was just kind of looking at my fall pictures recently that when I had the opportunity to get up and visit with Guy and Andrew and Travis a couple of years ago in the fall. So still have very fond memories of the first snowfall I got to see in the UP that year. So I look forward to today's discussions and thank everyone for your time and being engaged in this next strategic phase of growth for the GLRC and SSC and Mars. And I'm happy to turn it back to you, Travis, and look forward to hearing from my colleague, Charlie Tyson, with the Office of Future Mobility and Electrification.
Yeah, thank you, Emily. We really appreciate your support and all the comments. Next, I'd like to introduce Charlie Tyson, who's with MEDC and the Office of Future Mobility and Electrification.
Thank you, Travis. I appreciate it. Good morning, everyone. Hope everyone's having an enjoyable time during this this Smart Ships Coalition workshop. Travis, am I able to share my screen? I think so, right?
Yep, absolutely.
Alrighty. All right. All right. So as Travis mentioned, I'm Charlie Tyson. I'm with the Office of Future Mobility and Electrification. I'm the Technology Activation Manager. In my role, I spend a lot of my time working with companies locally and globally, finding ways to help them partner with Michigan entities, including universities, corporations, communities, transit agencies, and other Michigan small businesses and manufacturers. A little bit about the office. This office was created under an executive order through our Governor Gretchen Whitmer and under the current administration to really create a stronger state economy through more equitable and environmentally conscious transportation for all Michigan residents. Although this office has really been kind of an evolution of the former Planet M program through the Michigan Economic Development Corporation. Our office is unique, and I'll get into this, in that we have individuals from multiple state agencies that are working within the Office of Future Mobility and Electrification, or OFME. Although we see automotive as one of the main economic drivers here in Michigan, we definitely see mobility as being much more than just automotive. It's how I like to describe it is mobility is how we move people and goods from point A to point B by air, land, or sea, or waterways, since we're here in Michigan and have the Great Lakes as such a strong asset. We have 6 core objectives within our office. We want to grow the mobility industry, the maritime industry, automotive, aerospace, agriculture. Mobility plays a role in all of those. We want to engage more mobility startups globally. We want to expand Michigan's smart infrastructure, digital and physical infrastructure that can enable connected, autonomous, shared, and electric transportation. We want to accelerate EV adoption in Michigan, reducing the carbon footprint and working towards what Emily mentioned as the carbon neutrality goal by 2050. We want to enable Michigan's mobility workforce, ensuring that we do what we can to retain top talent coming out of universities like Michigan Tech, but also attract talent from all over the world, making it well known that Michigan's one of the best places to live, work, and play. We want to bolster Michigan's mobility manufacturing core, supporting tier 2, tier 3 small mom and pop shops that are plastic injection molding, electronics, etc., making sure that they are remaining competitive in a very rapidly innovative world. As mentioned, the office coordinates as a statewide mobility strategy that is championed by the governor's office, MDOT, LEO, MEDC, and EAGLE. So I'm formerly an employee of the Michigan Economic Development Corporation, but we are fortunate enough to work with folks from LEO, MDOT, and EAGLE. Our office offers the following services to businesses. We have a year-round grant program, which I'll get into, focused on technology activations. And we see technology activations are really testing activities or pilot activities. These are ways that we've seen as a way to support company growth in Michigan, helping them test and validate technologies in real-world situations or at test sites to obtain further investment, to work closer with universities, to identify potential customers and additional partners for them to scale. We also offer connection services. These have been done through matchmaking events where we identify demand in the market and then pre-schedule meeting between corporations and investors and even cities or communities. And then we find startups that have capabilities that are being sought after and pre-schedule those meetings and have private one-on-one meetings between the parties. We also do work one-on-one with individual or companies or entities in general that are looking to connect with other potential partners. We can tap into our vast database of companies locally or globally to share a list and see if there's any that might be a good fit to work with. We also, through the Council on Future Mobility and Electrification, which was also created through an executive order and consists of public and private sector mobility stakeholders, we provide policy support. That's done to provide legislators recommendations to make our policies attractive for companies looking to grow here. But we also can work with, are interested to hear any policy recommendations or have those discussions with anyone in the audience today. We also, do industry intelligence and, can provide viewpoints, comparisons, benchmarking for economic development opportunities, and have a lot of events that we support that would love to get any of you involved in if there's a good fit, or maybe there's a speaking role as well. As I mentioned, we have what's called the Michigan Mobility Funding Platform. This is our grant program. This is focused on catalyzing and scaling mobility solutions across the state of Michigan and in sustainable futures related to electrification, carbon reduction, equitable futures, making transportation more accessible to those that may not have transportation options, and then multimodal transportation. We're seeing a huge trend in maritime due to the work the Great Lakes Research Center, EAGLE, MDOT, and the Smart Ships Coalition have been doing, along with partners like Great Lakes Governors and Premiers. These partners have been really spearheading a lot of these initiatives. We also see multimodal transportation being, aerial mobility and drones as being is picking up. The application is a rolling application, so you can apply anytime. However, we do review the applications every 3 months. We have a review committee of public and private sector mobility experts that help us review applications. The mobility funding platform has 2 arms to it, or 2 different offerings to it. It has a real world deployment or a test site deployment. The real world deployment is for projects that proposed projects that are kind of in a community setting or in an area that is kind of a live environment. We also have a network of test sites that we partner with, and these are great partners to work with if you need a more controlled environment or needs a partner like a university, for example, to provide more expertise and support. I'd be happy to connect with anyone offline, and I can share my information through the chat box or have Travis share it to the group at a later date. You can also find the mobility funding platform on the link there, www.michiganbusiness.org. /mobility/funding/. A few projects that we've been excited to work on over the last couple of years. One is formalizing our partnership with the Great Lakes Research Center as one of our key test sites focused on maritime. That's the only one that we have in Michigan, and really is a leader globally in this space. So we thought it would be great to work with Michigan Tech and offer grants to companies that want to work with Great Lakes Research Center. And so through that, we're able to support a project with DocTech, an Israel-based startup, working with Michigan Tech's Great Lakes Research Center to install sensors to provide a safer navigation through digital mapping. We also, and you heard from Chris from the Mackinac Economic Alliance, we've recently been awarded a grant with Mackinac Economic Alliance and the Great Lakes Research Center to begin testing, to design a testing regimen to determine energy flow and direction, and really looking at a high level the ability to leverage the current within the Straits of Mackinac as a potential power source for future electric or hybrid ferries. We hope that we're excited to award funding to that and support that. And we know that our partners like Eagle and Emily's team are interested in supporting this over time as well. This would be kind of putting this playbook together, really puts partners in Michigan and ferry operators in a good place to begin implementing these hybrid or electric ferries. And as we look to explore federal funding or state funding for the implementation of these ferries, we would like to work with anyone in the audience on that. And then the last but not least, this was not through the Great Lakes Research Center, but this is through a real world deployment. LilyPad, a West Michigan-based startup, is developing the world's first aquatic mobility vehicle that is powered by solar panels. And it's essentially like an Uber on the water. They're really using it as like a way to provide people a seamless opportunity to experience the Great Lakes, really focus on inland lakes though. They are currently testing their first prototype in Saugatuck, Michigan. So this is a really interesting frictionless rental access for water recreation, and they hope to scale to different inland lakes and waterways in Michigan over time. So that's about it on the Office of Future Mobility and Electrification. I'd be happy to answer any questions or chat with anyone offline. Thanks so much.
Thanks, Charlie. It's a great presentation. We really appreciate it. And just kind of a reminder that with the Michigan Mobility Funding Platform, that's something that any of our Smart Ships Coalition members can take advantage of if they have ideas and projects they'd like to see happen here in Michigan. I'll quickly touch base on one other event that we're working on in collaboration with MEDC. MEDC is organizing a cyber boat challenge, and that will physically be taking place here on Michigan Tech's campus in the spring of next year. So we're looking at about the third week of May, and the event is geared towards education and outreach at the sort of the college level. We'll have students from many different universities participating in this, and it's sort of a hackathon type of event, but it also includes some lectures and some hands-on experiences with autonomous vehicles and components of those. And really the workshop kind of looks at how how these different vehicles and technologies work, and then sort of addressing from a cybersecurity and cyber threat aspect, how they might be vulnerable. And the hackathon part of the event will get the students working on solving some of those security risks with these different pieces of equipment, and trying to basically break into them and fix them. So it's a pretty neat event that we're looking forward to getting started this year. Hopefully it will be an annual event, and it's sort of based upon an already successful program with Cyber Truck and Cyber Auto. We'll certainly share more information with everybody as it gets closer to this time. And we'll likely have opportunities for folks within Smart Ships to get involved in this event in some way or another. So stay tuned for that. At this point, I would like to turn it over to the audience here for some Q&A related to the presentations from Emily and Charlie. I think we've got about 5 minutes or so if anyone has any questions related to the state of Michigan's work in this area.
Hi, me again, Transport Canada, Howard Poslins. There's a lot of synergy. So at the Transport Canada's Innovation Center, we're multimodal, and I happen to work on drones, on cyber, on autonomous ships. So I met Charlie at another occasion. It's the aerial mobility platform that the Ontario AVIN, Ontario Autonomous Vehicle Innovation Network. So we're working on that. So there's a connection there. The other connection is on the cyber. So we do have cyber projects related to automobiles and trucks. So I'm aware of the cyber challenge for the trucking area. So all that to say is all of these different modes basically can benefit from one another. And obviously working together with Canada and the US, I think that's a great idea. So it was just a comment. Thank you.
That's great, Howard. We hope that maybe when we get the Cyber Boat Challenge organized, we can invite some of your students to participate in that. As things get back to normal here, hopefully we can open this up and really get some exciting collaboration going.
Yeah, I put a note to myself to contact you on that. So that would be great.
Excellent.
Travis, if I could, hate to occupy so much of the time, but I'm interested, and from Emily in particular, I understand there are some rules, some of them are federal, Coast Guard rules and so forth, as we're looking at electrifying these ferry boats. They're in the 50 to 200 ton class. So there's regulations on how they can operate and so forth. And apparently there are some rules that if you do switch to electric drive systems, you still have to have a diesel backup in case your electricity dies or runs out or whatever. And when you're in the middle of the ocean or the middle of Lake Michigan. But these boats are just running 5 miles back and forth, and there's multiple ones doing it all day long. And so I'm sure at some point we're going to have to address what are the regulatory issues to do in such a thing, because it seems like way overkill to have duplicate drive systems when you're they never go out of sight, right? I could swim out to the boat if it breaks down out here. So anyway, I don't know if that's something that Michigan can get into, but we ought to, as we're looking at implementing this stuff, also be looking at what are the limiting factors, and that'd be one I would think.
Thanks, Chris. I think you raise an important question and point that we do need to consider and put that on the list of things. And it may not just be limited to Michigan. It may be a Great Lakes wide issue for some of our, I'm just thinking of like our Great Lakes islands that have ferry services that may not necessarily be in Michigan. So in Ohio, for example. So you point out an important issue that I think probably needs some more discussion at the regional level with some of our other colleagues across the Great Lakes region. And that's one of the areas that we focus quite a bit on with the Office of Great Lakes, is working collaboratively with our regional partners to help work through some of these policy or regulatory issues that affect some of the opportunities that may exist, and creating a larger forum for that discussion. So I made a note of it, and I don't know if it will fall within Eagle, but it's something that we can talk about in our work group that we've got formed with MDOT as well, and at least create a space for some of those discussions, and we can then bring that to more of a regional conversation. So thanks for raising that. I'm very familiar with the Mackinac Island ferries. I have my aunt and uncle live on the island year round, so spent my whole life on the ferry. So I look forward to seeing them being autonomous and electrified. It's really exciting.
Yeah, and that just to touch on the working groups, we do have a working group, and we'll talk a little bit more about that here shortly. That we hope will focus on some of these issues, with the policies and regulations, industry practices. So certainly would invite you to partake in that group, Chris. I think that's a great topic of discussion.
Maybe if I can make one comment and invite Andy Zigwig to reach back into his former employer and make some comments too. Coast Guard rules are evolving with autonomous vessels, but as it stands right now and with our agreements with the Coast Guard is we have to operate under what is called supervised autonomy. So there needs to be a certified captain watching over the situation. It isn't real clear in the regulations now whether that captain needs to be on board or not. But I've been very impressed with Andrew Zigweed's approach when he was at ASV Global about how critical it is at this juncture of development that we not have an accident. So Andy, do you want to fill in on some of those details? I think you really have a good approach on that.
All right. Yeah. Thanks, Guy. I was intrigued by the questioning. The Explorer class vehicles are entirely wind propelled and solar powered, and we've not experienced this requirement to have a backup, diesel in particular power generation. So that was something new that I hadn't heard before. But we work closely with port authorities and to do the notifications to mariners, and we are always constantly observing the vehicle's decisions on their paths in their autonomous path making. So we provide and broadcast AIS as well as receive AIS signals. So we're looking ahead on our missions and towards our waypoints to safely navigate waypoint to waypoint. So I don't know if I could, I'm still intrigued by that requirement. I had not come across that requirement before.
And
As I understand it, it has to do with the class, right? We're bigger ships, right? We're 200-ton ships, and we're carrying passengers. So I think that puts us in a whole different realm than you guys.
Yeah, I suppose it would. Yeah, so we're a uncrewed surface vehicles. We are not classed as ships or boats or vessels for that matter. So we're a scientific tool, and so maybe that's why I'm not familiar with that requirement. So that is something worthy of addressing, though, Guy, as we look to electric propulsion on these vehicles. The reliability, I guess, needs to be pulled into that consideration. Absolutely. And what if it was hydrogen fueled rather than diesel? That's probably more likely as we move forward.
And hey, Travis, this is Mike.
Hey, Mike.
I'll address some of those things in about
great.
20 minutes. So I think that I might shed some additional light on this whole subject matter, but I'll keep it till my 10:15 time slot. So just a little teaser.
That'd be awesome. I think we'll look forward to that. And maybe just a final thought is, it sounds like this is a great opportunity, where Smart Ships Coalition can help, even inviting speakers and trying to organize maybe presentations, whether it's from the Coast Guard or classification societies. These are things that I think we're very on board with helping to facilitate down the road. So please continue to share these types of ideas, questions, and feedbacks. It gives us a lot of good food for thought.
maybe in one final comment on that, Travis, if I could. With the economic development folks, you should not expect that operating autonomous vehicles is a cost saving at this point. There is a number of levels of detail that result from these regulations that require crews of different types in order to efficiently operate them and maintain them. But again, with Ocean Infinity's tremendous experience in doing force multiplying by having multiple vehicles under the supervision of a mothership is certainly a huge cost saving. So I'm very much looking forward to their comments. So thank you.
All right. Well, I think that was all we had time for questions. But if we missed anyone's questions related to some of the state level initiatives, please share those with us, and we'll try to address those after the fact. I just wanted to quickly mention one other thing, and that several folks even on the line here in the Smart Ships organization that represent manufacturers and shipbuilders. So that's a whole nother angle of this that we hope to explore further as a group, is the manufacturing, and how, as new vessels are being built and deployed, we can, work some of these issues out and deploy some of these technologies. So certainly would invite feedback on that topic as well. With that said, I would like to transition to our next speaker, and we'll learn more about some of the regional maritime strategies and initiatives from the Great Lakes St. Lawrence Governors and Premiers Organization. And we've got Mike Pisker here on the line to give us a great presentation.
All right, thanks, Travis. Good morning, everybody. First of all, thanks to Guy and Travis and Andrew and the whole team at MTU for organizing this. It's been a great session. Overall, great partners. We've been working with them for several years now, and really glad to see all the progress that's been made. We've come a long way in a relatively short amount of time, so this is pretty exciting. I do want to mention I'm joined by two of my colleagues on the line, Dave Napsker, our executive director, as well as my colleague, John Schmidt, who just joined us last week. John is going to be transitioning to taking over our work on maritime transportation. So I'm going to take the lead on this presentation, but Dave and John will jump in as appropriate. So I will bring up my slides here. Okay. All right, I trust you can see those. Okay. So quickly about our organization, the Great Lakes St. Lawrence Governors and Premiers is a nonpartisan partnership of the 8 US states in the Great Lakes region, as well as the provinces of Ontario and Quebec. So we work on a broad range of issues from regional economic development, aquatic invasive species, water management, and then of course, maritime transportation, which has been a huge part of our work for the last 6 or 7 years now. So as I mentioned, nonpartisan partnership, Governor Evers of Wisconsin is our current chair. And we've had really great success working across a range of issues. So maritime, this program was launched in 2013, and it came from the idea of looking at the region's maritime system as an underutilized asset. A lot of capacity existing already with current infrastructure that we could do a lot to make more of. So we spent a couple of years in the development process that led to a strategy for the Great Lakes Maritime System that was released in about 5 years ago in 2016. And you see those goals there of doubling maritime trade, shrinking the environmental transportation footprint, and supporting the region's industrial core. So, lofty goals, which we've gone about in a number of different ways that I'll describe. We had an exhaustive process of developing this, working with a broad range of partners from across the region, both countries, federal government, state, provincial, of course, industry, NGOs, and others. And it came up with about 30 or so actions of different ways to go about achieving these big picture goals. So everything from infrastructure to different policy issues. And even back then, we did have a small section around autonomy before we were really thinking about it, of course, and made the connections with Guy and Travis. So, again, really amazing to see how far this has come in a relatively short amount of time. Following that 5-year period of the strategy, we did just recently develop a 5-year action plan. So basically saying, we've had 5 years, we've had some great successes. What does the next 5 years look like going forward? And we thought about them in these different categories you see here. And of course, for the purposes of this call, that last bucket is going to be the most relevant in terms of stimulating innovation. A lot of different things that we have been involved in over the years. Smart ships, of course, with MTU and getting the Mars set up. Smart infrastructure, we've been thinking about this in the context of smart shipping and some of the digital infrastructure that might go along with that to boost efficiency, reduce the environmental footprint, and so on. And then also kind of fitting under that category would be green shipping, which is a newer initiative for us, but one that, of course, has a lot of potential, a lot of push from a lot of different forces. So I'll talk about that as well in the next couple of slides. So just a couple of quick highlights, some of the accomplishments that we've had coming out of this. We led the advocacy campaign for the new Sioux Lock. So, that was one that was in the works for many years, a lot of different people working on it in different ways, but it just never seemed to get over the finish line. So we were able to work on that with the regional coalition to get that project authorized, funds appropriated, and it is of course under construction now from the Army Corps of Engineers. So that's been a great boost for the region. We're now looking at different ways to ensure that the physical infrastructure is accompanied by appropriate technology. So for example, hands-free mooring technology, which is on all the locks along the St. Lawrence Seaway, only made sense that for the Sioux locks that technology would also be present there. So we worked with the Army Corps of Engineers, and that has been included in the work plan and the future budget for that project. So really glad to see that kind of uniformity of technology. We have a partnership with the Port of Antwerp in Belgium, which is the major gateway port for the Great Lakes to Western Europe. And we have a partnership with them based around doubling maritime trade with Europe. So, thinking about that big regional goal of doubling maritime trade overall, this is one segment of that. So we've been working with them on a number of different ways, and I'll talk about that in a bit more specifically in a moment. I mentioned green shipping. We have a green shipping action plan that was just released a couple months ago, and this has some different parts of it. We have a couple different pilot projects that we are spinning up, again, which I'll talk about in a moment. And then smart shipping, like I said, we've been thinking about this in a lot of different ways. There's a lot of opportunity, a lot of different things happening in different parts of the world around things like voyage optimization, just in time, lock management. So again, there's a lot there's some happening in our region already, primarily on the St. Lawrence Seaway, but there's a lot of opportunity to bring some of these new technologies to bear. In a lot of cases, some of the ports and others are using 50-plus-year-old technologies to go about their business. So definitely some opportunity for efficiency gains there. And then not as relevant for this group, but I would mention the Cruise the Great Lakes initiative. This is a partnership of the states and provinces, cruise lines, ports, and others across the region to help promote the Great Lakes as a cruise destination to consumers. So really created a brand and a logo and website and everything like that. And we've been working hard to boost that kind of niche within that, again, within that bigger goal of doubling trade. So a lot of different things here, but this is what we've been working on over the last 5 years or so. Western European trade, as I mentioned, looking at that as the gateway port. They are a global leader, they being Port of Antwerp, in terms of emerging technologies, sustainability, and there's a lot that we can learn from them. And they really see access to the kind of heartland of North America as critical to their business going forward. So great partnership in both ways. Dave and John, my colleagues, will be leading a mission to Belgium in about a month. There's a big trade show called Antwerp Excel that's been postponed a few times due to COVID, of course, but it will be happening here in early December. And a group of port directors and others from our region will be going there on kind of a business development mission. And then I talked about the smart shipping piece as well. So smart ships, we heard a lot about this, of course, already, but the role we've played in this over the last several years, we worked with Guy and Travis and Office of the Great Lakes in Michigan to develop a smart ships action plan. This was basically looking at some of the policy issues or where there could be specifically cooperation between the two federal governments to look at different ways to harmonize policy and really facilitate the growth of smart ships. So released that about 3 years ago, I believe, and have made progress in some different areas there. We worked, of course, with MTU and the state of Michigan on the opening of the Mars site. So, the picture here on the right is the opening of that. Dave Nafsker, our executive director, gave a speech along with, we had elected officials and a number of other folks there. So really a great event on a beautiful day, and the great launch of everything that's been happening since then. Helped to create the Smart Ships Coalition, of course, and kudos to MTU for running with that and building it into what it is. And then kind of leading up to all of this was a couple of missions we had to Norway to really learn about the great work that was being done there around autonomy, and looking at their kind of structure they had built as a partnership between government, research institutions, industry, and others really all focused on pushing this initiative forward. So, you know, in some ways, the Smart Ships Coalition was really kind of modeled off of that idea of, you know, broad-based collaboration. So we do have an MOU with the Norwegian Forum for Autonomous Ships. And then, of course, the partnership through the International Forum of Autonomous Ships, I believe is the name, as well. So kind of a global network that our region is plugged into. So, you know, kind of gives you the sense of the background of where this has come over, say, 4 years or so. Smart shipping, this was basically we convened a couple of different meetings over the course of a year and a half or so, thinking about different aspects of this and how to bring some of these technologies to bear. That picture shows some of the work that the seaway agencies are developing, as I mentioned, in terms of traffic flow management. So this is a project that's kind of in the pilot phase, hopefully will be rolled out in reality next year. And looking again at kind of improving the movement of vessels through the seaway locks, which will have cost savings, emission savings, fuel savings, and really be just a great step forward, bringing a cutting edge technology to bear. So like I mentioned, we convened a couple of different workshops based around, you know, learning about this initiative, thinking about kind of big picture goals and principles for the region in terms of smart shipping and efficiency and all of that. So starting from April 2019, and then most recently, some of a series of webinars that we hosted as part of our Leadership Summit series just last month or 2 months ago now, focused on a few different pilot projects and kind of analytical pieces that we've commissioned, which I'll talk about on the next couple of slides. So we worked with a consultant out of Germany, Hamburg Port Consulting, to kind of do a big picture analysis and recommendations for some of these technologies in our region. They were really focused kind of on the idea of quick wins. You know, what are things you can do to implement in the short term to show value and, you know, make progress. So that was a great effort and has really helped our thinking moving forward. I mentioned the partnership with Antwerp. We're looking at different pilot projects and potentially the idea of an innovation challenge. You know, kind of depending on a specific issue or geography. So that's something we continue to think about and definitely welcome people's suggestions for that. Most recently, we worked with the Axia Institute out of Michigan State University. They are a globally leading supply chain analysis kind of think tank out of Michigan State. And they did some analysis looking at the steel and taconite industry, which I'll talk about a little more detail on the next slide, in terms of what are some of the potential efficiency gains from smart shipping technologies. We're now talking with them about doing some similar analysis that would be focused strictly on the SU locks, thinking about, as I mentioned before, we've got the new lock being built. There's kind of a 8-ish year window of construction underway. Should be an opportunity to make sure that the kind of technology and digital infrastructure is built appropriately to go along with that physical infrastructure. So I mentioned this project with Axia Institute. It was looking at constraints in the steel and taconite industry, recognizing the centrality of that trade to Great Lakes Maritime, benefits of potential data sharing tools, including the Nextport system that was developed out of the Port of Antwerp, and looking at kind of the value proposition there for the supply chain. So this was kind of first piece of analysis. The results weren't as overwhelmingly positive as we had hoped, but nonetheless did make a business case for some of these efficiency improvements. So like I mentioned, now we're thinking about part of the thing that came out of this analysis, as well as some separate analysis we had commissioned, was looking at the SU locks really as kind of a choke point and really a single bottleneck in the system, where if some efficiency gains were made there, it could have huge kind of ripple effects throughout the system. So that's very early stages, but we are looking at that right now. I mentioned green shipping, so we worked with Green Marine. Oh, sorry about that. Oh boy. Sorry about that. Going a little haywire. Okay, Green Marine, which is based out of Quebec, they have a kind of global certification program for vessels and ports and others in the maritime system. We commissioned a report from them looking at, you know, kind of a survey of best practices globally understanding some of these new technologies that are being brought to market in, not in North America, but elsewhere in the world, thinking about how that can improve environmental performance in our region, and including a look at governmental programs, kind of opportunities for innovative financing, and then perhaps most importantly, short-term actions and long-term goals. So we developed an action plan based off of those. There's a lot involved in there. It's primarily focused around efficiency improvements, emissions reductions, future fuels, and things like that. So a couple particular pieces we are working on now is looking at a vessel emissions inventory, understanding kind of what is the current footprint of GHG coming from ships now, looking at the potential of analysis for electrification in the region, recognizing that the huge 1,000-foot cargo vessels might not be the opportunity now, but cruise ships, for example, are definitely an opportunity among other things. So really excited to see MTU's work, and we want to make sure that our efforts dovetail with that as much as possible. And then I would mention sustainable cruising. This includes a number of different things, including electrification. So I think this is my last slide. I mentioned, oh boy, sorry about that, guys. I mentioned the 5-year action plan, green shipping action plan, and some of those pilot projects. We're looking still to develop some of the smart shipping tools. We want to continue to support the work of MTU and the Smart Ships Coalition and keep the progress going. Trade promotion with Western Europe, and then we will continue, of course, our advocacy on big issues in the federal realm, especially the SULACs. So that is my presentation. As I mentioned, here are my colleagues and I contact information. Feel free to reach out with any of us. And, if there's any questions now, definitely happy to answer those.
Thanks for a great presentation, Mike. If the audience has any questions, we got a few minutes for that. If not, we could take a 3 to 5 minute break here and then regroup for our next presentation.
Travis, there is a question in the chat about the IMO MSC 103. I don't know if it's a good time to address that now.
Oh, yep, I'm seeing that here. So basically the question is whether if anyone is aware of the IMO MSC 103 outcome. So that's the regulatory scoping exercise related to autonomy and autonomous ships. I don't know that I have any information on this in particular, but does anybody else in the audience want to address that now?
Howard Parsons, Transport Canada. To summarize very succinctly and short and sweet, the IMO went through all of the various instruments to see how it affects or how autonomous ships would be effective. And the conclusion was it would be very difficult to modify all of the different instruments. So the de facto conclusion was there may have to be a special regulatory instrument for autonomous ships. They're not sure yet. And it would probably be performance-based. And everyone was sent back to their country to come back with proposals on how to come up with a specific regulatory instrument specifically for autonomous ships. So I'm not sure when the next meeting is. I can't remember when it is, but that was the homework that all of the countries had to do. So that's short and sweet.
Thank you, Howard. That's great.
It's probably written on an IMO. I think if you Google it, you'll see that's the result of the regulatory exercise on the IMO site. There is a summary of that. Thank you.
Excellent. Okay, we're at 10:15, so I think to keep things on track here, we'll start with our next presentation. So this basically, we are really excited to announce a partnership that we've been working on here at the Marine Autonomy Research Site testbed. That's between Michigan Tech and Ocean Infinity. Some of you may already be familiar with Ocean Infinity. They are a global marine robotics company that uses robots, as they refer to them, or ASVs and AUVs, as many of us might think of them, to obtain information from the ocean and seabed. I'll let our guests say more on that, but we're really excited to be working, very excited to be working with them on deploying and stationing a rather sophisticated 8-meter fully autonomous unmanned surface vessel at the Marine Autonomy Research Site next year, with the hopes that this asset will support a wide range of activities, including collaborative R&D with some of you all, ocean science, as well as education, training, and outreach. And hopefully much more. So the concept of operations will be for the Great Lakes Research Center at Michigan Tech to manage the operations of this asset and to have it available as a sort of a shared use tool so that our partners can interface with it. I anticipate our speaker's introduction and his presentations will get everyone's gears turning and thinking of ways that this tool can benefit all of our work around the Great Lakes region and beyond. And as the details are still being ironed out here, I certainly invite anyone with inquiries on possible opportunities related to this to reach out to myself, and I'll be more than happy to provide more information. So without further ado, I'm pleased to introduce Mike from Ocean Infinity, who approached us with this opportunity and has been instrumental in taking the steps to make this happen. In a very rapid way, actually. So we're hoping that we can have this asset deployed at the beginning of our next season, which starts around May. I also have to thank the Great Lakes St. Lawrence and Governors from Premiers for helping to connect Ocean Infinity with the Mars testbed and myself and colleagues at the Great Lakes Research Center. So at this point, Mike, if you're ready, I'll let you take it away.
Super. Well, thank you. Can everyone hear me okay?
Sounds good.
Good morning. And first, I must apologize. They're actually doing some construction outside of my office building. And as Travis and I were talking yesterday, my internet kept on going out. So I hope and I pray so far this morning, everything has been great. I'm based down here in Miami, Florida. And I'd also like to thank David and Mike for putting us together with the team at Michigan Tech, because it's just been a wonderful collaboration. And so let me just take a kind of a quick minute and introduce myself. Then with everyone's permission, I'd like to play a video that kind of introduces the capabilities of Ocean Infinity and who we are and what we do. And then go into kind of a summary presentation about why we're so excited about this collaboration with MTU, and really to kind of hit on some of the issues that have been really discussed this morning. I have really been very, very impressed by the presentations, and I think that Ocean Infinity can play a very critical role at taking what conceptually exists in academia, what conceptually exists in government, and what conceptually exists in industry, and put them all together. And that's really kind of what we do. Our motto is that we really want to create sustainable relationships while at the same time creating sustainable technologies. And what that really means is that we want to create these sustainable relationships between academia, government, and industry. And as we've talked about, there's a lot of parallel paths, but it's all designed to make our planet better. And that means from a scientific perspective, that means from an industry perspective, and that means from a government perspective. How can we all play nice to really make the world a better place, and do it all with a sustainable processing, using the oceans and the waterways of the world to help us obviously satisfy the human condition. So on that note, I'm going to try very hard to maneuver through technology and share my screen and start our video, and then I'll be back together with us and we can talk about some of the other things. So give me 1 second here. Can you guys all see my screen still?
There we go. It's coming on now. Yep, we got your video player loaded.
All right, beautiful. So hopefully this will work.
AUVs, which are autonomous underwater vehicles.
Hear it okay?
Yep.
And the start of it was to use them in scale that no one else had ever done before. in order to be able to either do work much faster or to cover much wider areas. Some of the projects that we've done, that we did in the beginning, and you may well have heard of, was a search for the Malaysian Airlines plane MH370, which we did in the Southern Indian Ocean. Disappointingly, we didn't find it. We also did a search for ARA San Juan, which was a submarine, an Argentinian submarine that was lost in the South Atlantic, that was successful. And since then, we've done all sorts of different projects for different people, different industries, with people with an interest in understanding what's in the ocean or on the seabed. So the AUVs are capable of operating down to 6,000 meters below the surface of the sea. They're able to go out on missions that last 100 hours, that's 4 days, before they come back up and need the batteries recharging. So what we're able to achieve with each of them in terms of exploring the oceans and going to places that no one's ever been before is truly quite breathtaking. One of the things I always find incredibly exciting is to see a photograph of marine life in places where there shouldn't really be marine life, yet somehow things are growing. And it's a real privilege to be able to go to parts of the world that literally no one else has ever been.
We work in the ocean industry, which now more than ever is driven by requirements for improvements in safety and minimising its environmental impact, and ultimately being more efficient. So we're building a global fleet of robotic ships, the Armada fleet. The fleet comprises different classes in terms of size. So we're going to be building some that are 21 meters in length, some which are 36 meters in length. And we've actually got some on the drawing board which are even bigger still. The size of the fleet is going to be at least 15 vessels, and with plans to grow it considerably beyond that. And they're going to operate internationally. So we're going to have a remote operations centre here in Southampton. We're going to have a similar facility in Austin in the US. And the vessels are going to deploy worldwide. So anywhere that you're finding offshore renewable energy, offshore oil and gas assets, or countries with hydrographic and exclusive economic zone mapping needs, we're going to have vessels. The vessels are under construction in Norway, so we've got a yard up in northern Norway building some of the boats. We've started to procure some of the key bits of equipment, some of the sensors that fit onto the platforms. We've been recruiting the team, so finally the team headcount is coming up with more engineers, more people working on the data side, more people looking at the maintenance and operations of vessels. All of the vessels are designed to operate very efficiently, so to burn as minimum amount of fuel as possible. So they're diesel electric with a large battery on board. So they're really like a hybrid solution. So we burn the minimum amount of fuel possible on the job, and that generally means operating at speed below 10 knots. In terms of range, the 36-meter boat will be able to go over 5,000 miles. So we'll have huge operating ranges. We can either stay at sea for a very long time, or potentially deploy long distance. So by deploying robots, we can cut down the number of people we send to sea, reduce the safety exposure of sending all those people to sea. We can significantly cut the amount of fuel we burn. The robotic vessels are proven to be more efficient than their manned counterparts. We don't have big hotel roads. We're not effectively putting a hotel at sea full of people. We're putting just sensors in the robotic vessel needed to carry those sensors. We can massively reduce our fuel burn, our CO2 emissions. But also we can be much more efficient. These robots can operate 24/7, can accurately follow their mission plans, and really run the areas, cover these huge areas of sea we need to cover very accurately, very efficiently, and very quickly.
The Armada fleet, which is our fleet of wholly robotic ships, is the next evolution of what we're doing in marine robotics, where we've taken everything that we've learned from deploying AUVs in large scale and said, how can we push this even further? How can we drive the use of technology and robotics to really, really push forward with what we're doing in our business.
So everyone can still hear me?
Yep. Great
Everyone,
video.
everyone didn't fall asleep? So, one of the things that is just really great about, Ocean Infinity and just our entire concept as it relates to, ocean sustainability is that when you do things in scale, you have the opportunity to obviously do much more of it. And as we know, whether it be inland waterways like the Great Lakes or it be the oceans in general, they're such massive places that in order to get really true coverage and true data set, you want to do it with some component of scale. And that's always been Ocean Infinity. So just to kind of give you a brief history of how we got started. So we originally got started as kind of a search and survey company. And our thought process was that can autonomous robots create a new dynamic for search and survey? And the short answer is, with the deployment of AUVs, we found that to be fairly reliable. And then we thought, well, if we could do X with one AUV, what could we do with 4? What could we do with 8? And could we develop technology in array system in a model that would permit us to do that? And so whereas conventionally, a standard search and survey operation in the ocean may cover 50 to maybe as much as 75 square miles in a given day, with our array of 8 autonomous AUVs and with our array of 8 autonomous surface vessels plus a mothership, we were surveying and searching in the neighborhood of 500 to 600 square nautical miles a day, which is exponentially significant, considering that your power draw and your impact on the environment is still related to a single ship. And so exponentially, we were being much greener to the environment. And we were obviously covering more actual ocean and more sea bottom, which obviously is important in these particular areas. We then looked at it from a probability perspective and said to ourselves, well, where is our biggest incremental impact in terms of sustainability on both cost and on the environment? And what we found out, and unfortunately, this will come across perhaps not sensitive, and I don't mean it to be that way, but it's people. When you deal in marine environments, particularly ocean marine environments, the impact of people is very, very important. As Dan, one of our managing directors, said in the video, when you have to sustain a hotel on the water, you're absolutely taking a lot of energy requirements just to sustain that hotel, to run the washers and dryers, to run all of the things that are necessary to support humans, in addition to all the fuel that you need to support the technology. And so we looked at what it would take to obviously eliminate the humans. And so we really started to focus on this concept of robots running robots. And in addition to humans, there's a lot of support things that humans need. You need food, you need to be exchanged. And a lot of our ships did work in the North Sea. And part of the North Sea requirements is that you have to have a very significant crew designation. And the duty cycle for crews in the North Sea is only 28 days. So depending on where your site was, if it took you 3 or 4 days to get to a site, it took you 3 or 4 days to get back from a site, you might only be able to spend 2 or 3 weeks on site before you had to come back in to simply change crews and to reprovision the ship. And that's all wasted energy. That's all wasted fuel. And then we started to look at some of these hydroelectric challenges and said to ourselves, well, can we truly run off diesel electric type applications? And thus we have obviously diesel generators, and we carry enough fuel for those diesel generators, but can we use the power of electricity to begin to run not only our electronics, which is necessary, but also run our propulsion? And the short answer is yes. And so the Armada fleet already exists. I know that in the video they said that we've committed to at least 15 ships. That's actually gone up now to almost 50 ships. We've actually brought on a secondary shipyard in Korea. And I've talked to the governors and premiers, I've talked to MTU, and I've talked to the DOT, and we're actually going to look to potentially build some uniquely specific ships using shipbuilders in the Great Lakes community and in the Gulf Coast communities to obviously bring that type of work and that type of employment here to North America. But we've also believed that in order for this to work, it has to be a partnership between academia, which drives the research and drives the innovation. It has to be a partnership with government, which opens the door to these opportunities without becoming over-regulatory. And it has to involve industry. Where is the monetization event that makes this type of investment on behalf of Ocean Infinity worthwhile? And we think that that all works really seamlessly together. There was talk just a little bit ago by Mike at the Governors and Premiers about the SULOCs and will they create a choke point? And the short answer is that if you can use autonomy and if you can use what nature naturally provides us, we don't always have to rely on large infrastructure projects. I always use this as just a small example, and this is not designed to offend anybody, but well before the St. Lawrence Seaway became kind of the mode of transportation for the heartland of America and the Great Lakes, the Erie Canal was a significant contributor, but it just wasn't big enough. Well, it wasn't big enough because of the economic engine that ship and marine transit required. That's very expensive. But could you run a greater frequency, but a smaller vessel that took advantage of some of these secondary and tertiary waterways to help invigorate and reinvent commerce along these areas that have long been abandoned? And then lastly, about obviously environmental sustainability. And so we right now have an active partnership with some of the top academic institutions in Europe, where we're looking at the use of salinity and saltwater in particular, in infusing that into clean and sustainable hydrogen generators. And the idea of those generators will permit the ability for essentially these robotic platforms to stay in the water, whether it be in an inland waterway like the Great Lakes, or whether it be something in a more remote area of our world's oceans for indefinite periods of time, because they basically will be sitting on their source of fuel, which that would be either fresh or salt water. And so that's going to come and manifest itself as a combination between what we're doing in industry and what academia and government want us to do. And then it's all about mobility. And so if you're going to use waterways, whether it be ocean waterways or lakes or rivers, what is it that we can do to help make mobility as efficient as possible? And so mobility obviously revolves around commerce. What can we move from point A to point B that can facilitate commerce in small, medium, and larger markets? And what can we do in terms of mobility to help move people? And does that take advantage of, again, what nature has given us in terms of exploiting the waterways, while at the same time being kind to the environment? But more importantly, if we move freight over waterways and we move people over waterways and we do it in an efficient green capacity, what does that do and how does that help in terms of what is considered conventional infrastructure? Does that mean that we have to ultimately build maybe less roads? Do we have less trucks on the road? Do we have less cars on the road? Do we give people more time back because they're not caught in endless traffic jams? And the point being is that we believe all that to be true. And so that's kind of the mission of what Ocean Infinity is looking forward to doing. And we thought that the best way to do that was, again, use the resources available. And again, that's why Peter at the Department of Transportation, ultimately, and David and Michael at Governors and Premiers, and ultimately the team at Michigan Tech, we've all been able to collaborate. And so what we have collectively decided to do is to bring one of our Armada 8 vessels up into the Michigan Tech Marine Research Center. And what I'm going to do just real quickly, if I can figure out how to do it, is just share a real quick picture with you of what that vessel looks like. Can you guys see my screen?
Looks great.
Perfect. So we call these either our Armada 8, or we call them our Seaworkers Unmanned Surface Vessels, or our USVs. These are 8-meter vessels. These do use a electric diesel generator. They have about 160-hour capability of unmanned autonomous work. They do have the capability of working up into sea state 5, which is fairly substantial. They are standardly equipped with a multi-beam sonar system. They have a retractable mast system. They have an integrated moon pool system. Here is kind of a cross section of what they look like internally. And it is with, really great excitement and with just great anticipation of what collaborative activities we're going to engage in for us to bring one of these vessels, as soon as we dot all the I's, cross all the T's, but to get them up into Michigan Tech's hands, really to create a collaborative platform that allows everyone on this phone call to come up with ideas and concepts, using the folks at Michigan Tech, and again, without me overstepping, probably Travis is a single point person in determining how we could best utilize this. One of the great things about autonomous platforms is that if they don't break, they don't get tired. And so this thing doesn't care if it works 7 days a week, 24 hours a day, 365 days a year. And obviously it's our suggestion that it does exactly that. Part of it is also to really create what the next level of not only autonomy needs to be, but also what the next level of sensing needs to be. And so just as an example, we believe in robots operating robots, which means that, again, just use an example, if there was a buoy, for example, in the middle of Lake Superior that needed to be picked up in the middle of January because it was taking some research information regarding the formation of ice in the middle of Lake Superior, that might become difficult from a human perspective. It might not be reachable. It might be more than the 12-hour duty cycle. Well, let's send an autonomous ship to do it. And then through collaboration with the appropriate folks on this call or the various academic departments within Michigan Tech or other universities that are participating, let's develop the right robot that we could integrate with this robot that can go out and service that buoy or pick it up or retrieve it or repair it, et cetera. And so part of creating the platform as the basis then gives us the impetus to then begin to develop as a collaborative activity other robots that can be attached to this robot that help us do what we need to do, whether those are physical robots or they're sensor or electronic robots. But it really allows us to have an autonomous platform that while having an adult beverage, we could be sitting in a room at the research center, and we could be piloting this thing all under the auspices of being warm and not having to have thermal gloves on or being subject to the environment, but doing it in a really professional, what I'll call control room type setting, and not only at Michigan Tech, but all over the world. As Dan had shared in the video, we now do have 2 fully functional control centers. They do mimic the pilot capacities of various size ships. One is in England and one is in Austin, Texas. And the idea is that with multiple fully equipped control centers using the appropriate cybersecurity protocols, we can literally have global 24/7 monitoring and application of these ships based on a shift type environment. So when someone's done piloting and taking care of the ship, they can punch out and go home, which based on maritime type application does not exist in today's environment. That's also true, obviously, in freight based. It's also true in human mobility. And so, those are things that we're super excited about. I really am super excited to be part of the Great Lakes community. To just share a quick aside with you, when I first married my wife, which was a woman from South Florida, I moved to Grand Rapids, Michigan for 6 years, and we had our first of 5 children up in Grand Rapids. And so Michigan still has a very dear place in our heart, only because it's where I started my adult life, with my bride at the time. And I'm happy to say that we've been together 32 years, and so Michigan was very good to us. And so that's kind of what I got. And so at this point, hopefully I was able to innovate and create some excitement, maybe even some questions. And so I'll kind of volley it back to you, Travis, and see if there's some questions that might lead our dialogue. Thank you for letting me participate.
Yes, thank you, Mike. A super interesting presentation. We're very excited to be working with you, and also excited about the opportunities for you and other members of Smart Ships to network and start to develop some interesting opportunities here with this asset. So thank you and welcome. I'd like to offer up a few minutes here for the audience if anyone's got questions or comments related to this.
I did want to comment one more thing, and that is, particularly what Chris had shared about the Mackinac Island and the Mackinac Island ferries. And so we have a pretty sophisticated and, we've gone down this path quite a bit in terms of, people mobility in Europe. And we've actually engaged in some pilot programs in using these devices as water taxis, and not the Armada 8, but some of our larger platforms. And the idea of using a robotic autonomous platform to move people, and we've primarily looked at them in markets where there's this really predictable migration based on commuting. How many people go this way in the morning to commute? How many people go the opposite way in the evening for commute? And can we significantly lower emissions and infrastructure requirements by taking cars off the road? We've also used them on the smallest scale, thinking about your jet ski application in some of the ports in and around Europe, implementing what we call a micro logistics project. And that is, most of us are now very, 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 very intimate with the challenges in the global supply chain. And so one thing you don't think about is that when there are 80 container ships that are sitting off the coast of California, well, those ships, again, those are complete living organisms. They're basically hotels. And so they have people on board, and those people need things. And if those ships don't regularly get to port, they can't get the things that they need for the survivability of the people that operate those ships. They run out of supplies. And so the idea of running on-demand micro logistics that allows you to service ships, oil platforms, wind farms, with a kind of an on-demand micro logistics project where you can order something from Amazon, and through something like a jet ski, it autonomously makes its way to a container ship in the middle of the Pacific Ocean within a certain radius of the shore, and delivers that life-saving medicine, or we ran out of steaks, or I ordered a new game for my Xbox. Those types of micro logistics opportunities also are something that we've piloted, and we did it specifically with small consumer parcels between the Isle of Wight and Southampton, England. And it actually worked pretty well as part of the Queen's Maritime. So we're very, very into innovation. We're very into looking at medium-term and long-term goals, and we're very, very into investing in the physical infrastructure to help achieve some of the things that come out of academia and come out of government, to help show that this is in fact the path forward. So again, thank you for that.
Thanks, Mike. Any questions?
Well, I hate to be the guy that always has the question, but so again, Chris from Mackinac. Mike, I'm interested. We would be looking for somebody to help us sort of analyze not just the ferry boat service, but as you were saying, we're moving all sorts of stuff, right? We're moving, the folks we have 46 islands here in Mackinac County. We have ferries running in some places and not in others, and a variety of companies, and and we're also moving goods and trash and everything else. We feel like we need to get some sort of analysis done of what's moving where and so forth. Nobody wants to talk about it, but we also move stuff through pipelines, and of course we have a bridge and stuff like that. And so how all those things connect together, how many tourists drive across the bridge to get on the ferry boats here in St. Ignace instead of in Mackinac City, and can we optimize that and so forth. So it seems as though some sort of analysis of what's moving where. A lot of it's, there's certainly ships going through the area hauling iron ore or what have you, but a lot of it is just very small local movements. And so it seems like some analysis up front of all of that, how to best optimize all of that, what types of equipment, how to do it, when to do it, and so forth. Is that something you guys help with, Mike? Is that more of a transportation planning person? Just curious. I'm sure the Michigan Tech folks would love to help us out to analyze that as well.
Well, and Chris, that's exactly why this type of collaboration between government, academia, and industry, and then you overlay us on top, is absolutely ideal. So, I would probably volley that question to the academicians that are on the call. But that's exactly why I think associations and groups like this are so incredibly valuable, because, would we do the survey? Probably not. Could we help fund the survey? Sure. And could we help implement what we'll call the best practices and the suggestions that a survey like that should and will obviously produce? Absolutely. And so it needs to be a collaborative effort. But just to comment on what you said, one of the things that we have kind of introduced on our side, which we think is kind of interesting, is that in shipping, because you have limited assets and you have limited what we'll call pathways for which these ships move, it's all about predictability. And we've actually introduced a concept which we call the mathematics of randomness, and using artificial intelligence and truly what we'll call robotic land-based dispatch platforms. Can a ship or a series of autonomous ships or platforms work on an on-demand AI-based environment where they just kind of do things based on the need to do them? And will that need to do them, in fact, actually produce predictability? And so, we as humans, always want to put everything in, we need to do this first, we need to do this second, we need to do this first, third. And when we get in that path, sometimes we become inflexible because it just kind of works and it's an easy thing to do. Doesn't mean it's the most efficient thing to do. And by using, again, a platform that can run 24/7, 365, using land-based operations, using technology, using artificial intelligence, can it really be on demand? So when someone needs to move from one island to another, can they just call on the unit and the best and closest unit will just come get them? When trash needs to move from one island to the dump, can it just be called on or scheduled and just come do it? And the short answer is that with the right technology, the right platform, and the right size platform, all of that is possible. And it's that implementation component that we want to offer to this group, is that even the best laid plans, you still need somebody that's willing to invest in infrastructure and actual assets. And that's what Ocean Infinity is willing to bring to the table, understanding that this isn't going to happen tomorrow or the next day. This is a plan that we have to, crawl before we walk, walk before we run, but we want to be there with you guys along the entire pathway.
Excellent, excellent. Could I just follow up real quick with that, Travis? There's a lot of parts to this, right? And you guys are great on the technology and stuff like that, but then sort of this upfront planning piece, is that more of just a transportation planning person that we need, or what do you how do you propose we look at an issue like that and go about it? Because like I said, I've said many times, there's lots of money out there. I just have to have the right project to go get the money to fund. So I'm ready to do that. And you guys have got a great team I've had a lot of pleasure working with and some success, and I'd like to keep that ball rolling. So, but I don't know, who would actually do that type of work and that sort of analysis. And I don't know that either, but that'd be my next question.
Yeah, I don't have an answer right offhand, Chris, but I think that, that's a good opportunity, for networking through the Smart Ships Coalition here. Also, we do have some folks, on the call who are involved in Michigan's transportation and possibly have, connections well beyond that.
Yeah, and I'll take it one step further, Chris. One of the things that Ocean Infinity has committed to doing is that, if we decide that we have to build a widget that does this, we're not only willing to do it because we're doing it now, but we're willing to engage the basic geography of the region to help us do it. So, there are shipbuilding facilities that perhaps have been adversely affected just because of globalization. Maybe they're in Ohio, maybe they're in Michigan, maybe they're in Wisconsin, and I know of a couple of them. But think about how neat it is for to be able to say, hey, we need this thing that does this, to solve this problem at Mackinac to create a sustainable solution. Ocean Infinity is willing to build it and operate it. And by the way, we're going to go to Joe's Boatyard in Saginaw, Michigan, or Holland, Michigan, and contract them to build it. And so the idea is to really embrace every vertical component of the community to help the community. and to create economic drivers from, building it to supporting it to operating it to ultimately creating the ultimate economic and environmental impact that we want it to have.
Excellent. Very cool. Thanks, you guys.
Thank you, Chris. All right, were there any last questions here before we move on to the breakout sessions? All right, well, thank you for a great discussion there. The next part of our agenda is basically to kick off a working group discussion. So one of the major goals for this group, the Smart Ships Coalition, is to exchange information and work together to address some of the obstacles and opportunities that we've got in common and have heard a lot about today. This includes many things like addressing regulatory matters, industry standards, preparing our workforce, creating workforce development and training opportunities to meet some of the emerging needs. So we believe that one way to tackle some of these things is as a coalition and convening these working groups where members can have a very open dialogue with other members to discuss new initiatives and develop some strategies, and even further taking actions that we can all use to advance everybody's opportunities in our respective maritime realms here. So at this point, we're going to do a breakout activity with 4 different sessions. We've identified some preliminary working groups based on feedback from all of our members here. That includes a steering group, which the goal for that will be focusing on the sustainability and the organization of smart ships, trying to identify some opportunities and strategies to keep this group engaged, to bring in new members, and to add a lot of value to everybody that's participating. We've also got a group focusing on workforce development, identifying and addressing some of those educational gaps and needs and figuring out ways to address those. Obviously, there's a lot of academic partners, but also we want to hear from industry on what are the things that are urgently needed that may not be available right now. We've got an operations and policy group that will focus on some of the issues like we've heard a bit about already today regarding the regulatory framework surrounding our industries, and looking at ways to break down some of the obstacles and have a very practical approach forward. Of course, we've been working closely with U.S. Coast Guard and others, so we hope that they may also be involved in these discussions going forward. And then last, we have a technology development and applications group looking at ways to test and deploy new technologies. So I would invite everybody here to identify a group that they are interested in, and I'm sure there may be more than one group for many of you, but I would ask everyone to participate in a group brainstorming activity where we'll try to identify some topics related to each of these categories that we can explore more in future workshops and events with Smart Ships. We have a moderator for each group that will sort of explain the activity in more detail, but we'll be using a Google Jamboard, basically a big whiteboard that everybody can add Post-it notes to. So I'll lead the steering group with Dr. Meadows. Tim Havens will lead the technology group. Mr. Brent Burns from Michigan Tech, he's our Director of Research Facilities and Federal Relations. He'll spearhead the regulatory working group. And then we've got Miss Beth Hoy, who's the Director of Business Development and Programs here at the Great Lakes Research Center. She'll be focusing on a work group for workforce development. So let's see, our time right now is 10:55. Let's allocate about 30 minutes to this activity and then reconvene. To make it easy, we'll reconvene here at 11:25 back in the main Zoom session that we're all in right now for some closing remarks. To get into these breakout rooms, this is something that I was not familiar with in Zoom, so we've got a couple steps here for you. If you look at the bottom of your Zoom screen, there's an icon called Breakout Rooms. If you click on that, it will bring up a box with the different groups. So we've got a steering group, we've got an unassigned group, so we're all in that now. We've got steering, policy, workforce, technology. You can all join one of those groups or feel free to float back and forth between them. And then we'll reconvene here in this main session at 11:25. So we look forward to having the breakouts with you all. Thank you. Okay, I think this is most everybody leaving the breakout rooms and returning to our main session here. So thank you all for participating in those. Kind of the last item here on the agenda was just to do a quick debrief and discuss some of the some of the highlights of these breakout sessions, and then we'll hear just a few closing remarks from Tim Havens. So I can start with a really quick debrief on what we talked about in the steering working group. So on that topic, we discussed things ranging from, looking at ways of, aligning our priorities and focuses with various funding, whether it's at a regional or national level. We talked that one, productive activity we can start with is outlining a clear process of engagement and priorities for Smart Ships Coalition, so that as we're having these discussions, with others, that will help us easily see how we are able to align with their goals and priorities. This might pertain to funding opportunities or projects specifically. We sort of emphasize a point of, looking at Smart Ships Coalition as an opportunity to have this consortium where everybody is a stakeholder and has a voice at the table. Again, starting with drafting a list of priorities and applications. And from there, as we all kind of pursue our own respective interests, we can find the right, projects and funding opportunities. We discussed kind of new business models versus old business models, and looking at legacy systems. We heard a bit of discussion about thinking, I guess, kind of thinking out of the box and not being stuck in the way things have been done in terms of finding sustainability models and funding opportunities. One of the ideas in terms of how Smart Ships can provide benefits to our members and keeping folks engaged is working on bringing together groups of experts, even for things like reviewing projects and ideas, and providing members with some feedback and analysis on some of the different project ideas that they have. And lastly, a focus on sustainable relationships between government, academia, and industry. Noting that as Smart Ships Coalition moves forward and we identify some opportunities we want to pursue together, it's very likely that investment can come even from within here, as there's projects that where all these things intersect, where there's benefits for everybody involved. So that's the quick update, and we'll hopefully have much more discussion on this when we meet back in person at our next workshop. Beth, would you like to give a quick update on some of the workforce and education ideas?
Sure, Travis. Let me start. Here we go. So I was a breakout room of one. So full disclaimer, these are Beth's ideas. So to kind of kick things off, I think one of the first things is to try and identify current and emerging workforce needs, whether it be in the application of technologies now or in the development of new technologies, and then also in the down the road longer term use and maintenance of technologies. SSC could be a resource for sharing information on training and education opportunities. There would be an opportunity for Smart Ships Coalition and its members to help increase the awareness of and market employment opportunities, highlighting careers to educators and future employees. There's an opportunity here with the multi-sector network to provide some real world experiences to not only create awareness, but kind of create that buzz that we see, I think, right now in the automotive industry and with aerial drones. We can bring that to the marine environment. Related to Derek's posted, they got put on the line with workforce development. I think that there's an opportunity to try and help identify job classes and then map to those job classes the types of training needs that have to, be brought to the market. So an example would be, and I've seen some great examples within, I know, MDOT, where they have different types of positions, levels of education, pay grades. But as an example, ROV operators, what are the training needs for ROV operators, common pay grades, and similarly all the way up, into other areas like autonomous marine traffic control supervisors. So I think that in order for people to understand the career opportunities, they have to understand the jobs that are available and then what type of training that they need. Develop multi-sector approaches to education and training and seek funding opportunities. I know as an academic institution, we've pulled together a few proposals and tried to grab multi-sector partners. This is an opportunity to really take a step back, I think, and come up with a more comprehensive approach, and then go out and seek some funding opportunities to help fund workforce training and education programs. We definitely need to continue in everything that we do to explore the lessons learned across the other modes. They're already dealing with training and workforce needs. And so we should be cognizant of not reinventing the wheel when possible. And then I think that there are training programs out there that might not be publicly available. So if we look at some of the, specifically some of our governmental partners, Navy and Coast Guard, who are already using a lot of advanced technologies, they're already training people. How can we bring that training more out into the public so we can help to build that workforce more rapidly?
Great. Yeah, thank you. Some great ideas there. Brent, I think you might have been a group of one also on the policy side of things. I don't know if you had anyone join you.
Didn't have anyone join me. However, the policy world is it's very interesting in how this is going to play out. So it's an exciting group to have. Just a couple of things I just put down as questions that can be stored for later for future discussions for the Smart Ships Coalition. Broad question, again, more regulation or less regulation? It all depends on advancing technologies. At the same time, if there's no regulation, sometimes a lack of rules also doesn't help advance technology. Multi-level governance, definitely an issue. I won't, it's a reality with local, state, federal, international, interstate, you name it, from the options there. One question that recently came up with, I'll say the supply chain issues, for example, with coastal ports. Right now, I just heard something, labor policy issues. So this would be policy of automation of ports was brought up as a potential issue with one of our supply chain issues happening right now. So not in the water, but on the land. Is that going to be an issue? I think we all can agree it will be. How are we going to work through those issues with both policy and politics as we start to automate previously non-automated vessels? Another thing to think about is, the standards and operating policy development, which is more back to the paragraph. Where to start? Where did they end up? Where do they overlap? Kind of connects to that multi-level governance question mark as well. I'll let the technology development group talk about how their overlapping ones come in because they wrote those down. So
great.
Hopefully that adds a little context to it.
Very much. Thank you, Brent. And no surprises with this group. There's a lot of post-it notes in the technology development applications box.
Yeah, so Andrew and Randall and Derek and I had a good discussion about the technology. I mean, it's certainly for the engineers in the room, this is the exciting place. We like to make cool things that go fast and do fun stuff. So some of the things we talked about, one of the initial comments was we need to come up with a way such that we can get materials out to the SSC that talk about the various technologies and resources that we have, so that when you're at conferences, when you're visiting other people, that you have something that you can hand to them and say, hey, this is the great things we're doing up at the Mars with Michigan Tech. And so I think that's something that we'll certainly follow up on there. On the technology side, cybersecurity and digital threat for marine systems and ground stations, that communication between the systems and the ground and the ground stations that are controlling them. The cybersecurity of those systems is really important. We want, as Guy said it earlier, we want to make sure that we don't have any accidents. We can't afford that to happen. Correlation of the technologies that are being developed to applications. So can we create some kind of taxonomy or roadmap that maps these tech to certain applications, so that when somebody comes in and says, hey, I need to do this, we automatically know, okay, these are the systems that can accomplish those goals. Energy management is, of course, is always important to autonomy. So from everything from running out of electricity during a mission, resupply, onboard charging and management of energy, endurance, how long duration can we run these things, robust and accurate communications. So a lot of these systems require communications with the ground station, or we want to have communications such that we can continually collect their data. So making sure those communications stay online and are accurate, that we can trust them. Robust sensing and algorithms. So what are the right sensors for certain missions, for certain vehicles? How many sensors do we need? What modalities do we need? What are the algorithms that are used to apply to those sensors? That's kind of my world that I think about a lot. And then before I get into the various applications we talked about, then we started to kind of overlap into the other quadrants here, especially policy and education. So one that came up is a lot of the autonomous systems that are going to be developed and actually used won't be the unmanned systems. They're going to be the in the middle of those autonomy levels, things that assist people and allow workforce multipliers on ships, so that you can run a ship with fewer people. So how do we make sure that we're qualifying supervision of autonomy in the current Marine workforce? What kind of education do we need to have for them, certification, et cetera? Then we kind of went over and overlapped with policy and on certification of technology and regimented testing of this technology. So eventually, these systems will need to be certified for safety, for performance. And who does it? Well, my belief is that we should. We have almost everything we need up here at the Mars, as Guy talked about earlier, the different types of environments that we have. Impediment of government regulation to tech development. This is something that came up a few times during today's discussion. How do we make sure that we work with government so that we can move policy along, so that we can actually develop technology and not be hampered just by the policies that exist currently that are becoming antiquated? And finally, fail-safes, fault tolerance. So, and this is also related to the certification of these systems. How do we produce software and firmware that we know is going to not fail in the middle of a mission, cause an accident, and then be tolerant to faults? So the last thing we talked about was a whole bunch of applications. We just tried to create a laundry list. So everything from long duration and wide ranging science missions, the science suite. Certainly we're using autonomy quite a bit for that these days, with like the USGS fisheries, the sail drone sailing into hurricanes and taking measurements, but things like mapping, fisheries, people moving. I was really excited to hear today about possibly creating autonomous Mackinac Island ferries. And I kept thinking about what's going to be the Sheplers. Is it going to be the easy way still, or is it going to be like the autonomous way? I don't know. Shipping, of course, is going to be huge. That's going to be a big movement economically for this industry. Security and surveillance, defense, of course, electrification is part of this. The autonomy and how autonomous ships and electrification come into play. And then also, I think that, let's see, is this sticky note cut off? Hold on. There we go. Hybrid autonomy. So mixing together marine autonomy with terrestrial autonomy with aero, and how all those fit together, for example, into shipping. Could you have an autonomous container boat pull into port, unloaded by autonomous systems into an autonomous 18-wheeler? of course, it's coming. So that's about it for us.
Awesome. I think we've had a lot of good ideas come up about this activity here, and I guess to kind of put a wrap on things, I know some folks had to sign off, but we're going to have a recording available of this workshop, and I know quite a few people had reached out letting us know they would be looking forward to watching that. So I'd like to thank everybody that was able to tune in and participate. It's been a great workshop and nice to connect and hear some of your ideas in a little more detail. I'd like to turn it back over to Tim to kind of provide a few closing remarks, and certainly we look forward to more of these types of activities, and especially in person as we can do so.
Yeah, thanks, Travis. And I echo, Travis's statements. Thank you to everybody who was able to attend, and thank you to all the speakers. This was a really interesting workshop for me. My first Smart Ships Coalition workshop, and I can say that this is one of the best workshops I've attended in a really long time. I think the only downside is that it wasn't like out in the countryside of the UK or something with good food, but we'll solve that next time. And we've got lots of countryside up here. And so, some of the things that I just want to reiterate, and I'll make these quick because I know that the wrap-up session is when everybody just, okay, it's over. But I just want to reach out and say, hey, if you're up here, if you're visiting the area, please, get in contact with us. We will be very happy, to invite you to the GLRC and show you around everything if you haven't been up here already. This whole thing is about collaboration, and please just anything, reach out and talk to us, whether it's brainstorming, whether you have ideas, and of course if you have funding, that's the business we're in, that we're here. We've got a lot of experts in autonomy and sensing, and we'd love to help. A couple things that I wanted to point out, and so this is, I'll just show you a picture here. So currently the one thing that we're doing is Michigan Tech now has a Grand Traverse area location. So here you can see a bunch of government folks, and Jay Meldrum's in the center, who's running our Grand Traverse area office. That's President Rick Kubek from Michigan Tech next to him. So we are now down in Traverse City, which of course means a closer connection with the Great Lakes Water Studies Institute at Northwestern Michigan College and the Maritime Academy there. We have an MOU with them, and so that opens up a lot of opportunities for not only testing up here, but also testing down in Traverse City as well, and utilizing the expertise that they bring to the table too. So keep this in mind. And finally, some upcoming events I want to point out: Cybervote, in the end of May. Hopefully we'll have an in-person SSC workshop in 2022, announcement coming soon. That'd be really fun to meet everybody in person, have some nice meals. Recordings are going to be made available. Please answer our survey, and just, thanks so much again for joining us today, and don't hesitate to reach out. So thank you to Travis and everybody for putting this together.
All right, we'll see everybody at the next event. Have a great weekend, everyone.